Hey, what's going on, everybody? How are you doing? Happy Saturday, chat. From me to you, I hope you guys are doing super good. We're going to kick things off right into some more Kerbal Space Program here. Today, what I'd like to do is test, so some of y'all, Ubinator, I actually think it was you and somebody else on the Twitch side as well, suggested looking at implementing the derivative form of proportional integral derivative controllers, basically also known as the velocity form. There's a difference between that and what we were using, which is more tied to the actual error versus using the change in error. So off stream, I rewrote our PID controller Python code in order to incorporate this change, and now we got to kind of go through, make sure it's working as expected, and then probably have to retune all the controllers, right? Because the velocity design, basically the derivative design or the delta design of a PID controller uses the change in error, and typically when you're working with changes in error or delta error, you have much smaller values that you're working with in comparison to using what we were using, which is just using the error itself. And so you can imagine when we are very far away from our target, we have a huge error, and then our PID loop, proportional integral derivative terms, use that very large value. But yeah, like I said, I went through and redesigned our PID controller here in order to use the actual delta error. So we'll see exactly what happens and what we actually have to do to make this work. So yeah, I'm doing great. What about you? I'm doing pretty good. What's up, King Crab? How are you guys doing? Hope you guys are doing well. Yes, so that's what we're gonna have to start working with. So I don't have it here side by side. Y'all can see it on GitHub, the old code. I won't push this new code to GitHub yet until I know it's working. But yeah, essentially, if I could show the old code side by side, actually, you know what? I can show the old code side by side, can't I? Yeah, so I redid pretty much the entire PID.py here. Simplified a lot of the values that we were using, and it's primarily the change was in the update code. So as you can see here, we were essentially using the error directly, which is the difference between our current measurement and our desired measurement, or our desired point. So for example, for landing a rocket onto the pad, our error, or our set point, was the pad latitude and longitude, and our error was however far away we were from the pad. So we were using that error directly. I've now since changed that to use the delta error, which is the instantaneous change with every time step that this runs, the change in error. Which some of y'all brought up as a good point, to try and smooth out some of the controller, because we were getting a lot of oscillations, and that's because it was, you know, the PID controller is working with large values, or at least that's one of those reasons. So we'll see what happens, chat. I have no idea. We gotta dive into the code here and test it out. We'll probably use the DCX vehicle because it is our test article, and we're gonna be doing a whole bunch of stuff like we were many months ago, and just making sure that our new control system is operational. That's what I got planned today, chat. AOA limiter, maybe. Yeah, there's a lot of things that we can do with that. Yeah, gotta love Visual Studio Code. It is very nice. I do very much like Visual Studio VS Code. All right. Yes, I want this. We're gonna go ahead and get we're going to get our dedicated grounds crewman Thomas. There we go. Fly. Good. Hey, Craig, how are you? Hope you're doing well. And Space Plasma, good to see you. We have Space Plasma on Twitch, and we have Space Gravy on YouTube. Yeah. What happens when you combine them? Spicy gravy. All right, chat. So yeah. you guys know this very well. I'm sure most of y'all have seen us fly this a ton, as this is our test article. It is designed to basically do everything on a small scale that we eventually want our new Glenn reusable style of rocket to do. And so this is what we use to test. And we'll see just how, well, first we have to make sure our PID controller that I implemented is actually implemented correctly, because I have not tested it yet. We'll see about that. Moved to the UK last month. Well, that is one heck of a move then, depending on where you were moving from. But heck yeah, there you go. I hope everything is going well. Hope the move went smoothly enough. All right, now we just got to put this on the pad as we always do. Hope that the wheels don't buckle, because these wheels are very underpowered. These rover wheels, I don't understand. I know I have said this before, chat. I do not understand why the slightly larger rover wheels, like the truck wheels, are locked at the highest tech tree point. Like, we basically get the teeny tiny little rover wheels, and then we get these rover wheels, and then nothing for like a lot of different slots. And I don't understand it. Don't understand it, but hey, whatever. If I really wanted to, I could change that. So no use in complaining, I suppose. All right, let's go ahead and bring that out, bring that up, bring that out to 90. That looks good. And landing gear down, turn the volume on. What about the Apollo rover wheels? Yeah, those little tiny guys, those are much smaller. Those are much smaller. Well, I mean, I guess they're kind of about the same size, aren't they? I actually haven't done a side-by-side comparison. Our little, gosh, what did we call it? Mobile utility vehicle, surface vehicle. Sorry, yeah, the surface vehicle that we designed not too long ago uses those wheels in tandem. Go ahead and bring that up a little bit here, bring that down, and we can go ahead and drop this and boop, and wheel it away. Perfect. A lot of lean on that. Yeah. The spring strength, I think, isn't the spring strength maxed on this? I actually haven't checked that. Oh, it's not maxed. Oh, well, hello. There you go. That was a good thought. I usually do max out spring strength on vehicles like this that carry a heavy load, but I guess whenever we developed this, however long ago it was, never changed the spring strength. So that is something that we should maybe do in the near future. Go figure. All right, let's go ahead and fuel it up. Fuel it up. Let's go ahead and figure out what we need to actually do. Hey, what's up, Zonal? How are you? What do you think about strata launch and pros and cons versus launching traditionally from the pad? Personally, I really like the concept of strata launching, right? Like, Strata Launch, the company, is not the first company to actually do air assisted launches. I like the concept. I think it's kind of tough. I'd like to see what they can do. The problem with air launch systems is that you can only make your rocket platform so big, right? Because you need something like an airplane to be able to carry that. So the reason why Strata Launch Company seems to be able to do what I hope a lot within the space realm is that they made the largest carrying lifter plane ever. Like, it can carry, I don't even remember what it was, like 150 metric tons. It can carry a stupid amount. It's probably not that high, but like, I just remember like hearing it's a lot. It's a fully fueled like Falcon 9 first stage, because I remember Strata Launch and Strata Launch and SpaceX were looking to partner, and Strata Launch was going to launch the version 1 Falcon 9 or something like that. It was crazy. It was a wild concept. But anyways, so you're going to be on air launch systems limited by your carrier vehicle. I honestly think what SpaceX can do kind of makes air launch systems, I wouldn't say obsolete, just not as valuable, right? Because the whole point of using an air launch system is that you can launch it from, 30,000 feet, where the atmosphere is a lot thinner than here at sea level. So you get a lot more specific, not, well, yeah, you do get more specific impulse. You get a lot more efficiency, right, burning at that higher altitude. Unfortunately, though, that's also somewhat negated because when you do an air launch platform, it almost goes completely horizontal and has to go vertical to get out of the atmosphere. So all of that propellant that you burn just to go from here to push up, you know, kind of also reduces its value proposition. It's a tough one. Like, I think it can work. I think it can be competitive. It's just, I think it takes a lot to get there, like with any launch company personally, but I have high hopes for Shadow Launch. I like their business plan of going hypersonics first, because there's a big push in the DoD sector right now, the Department of Defense, to look at hypersonic testing. And that's exactly what Strata Launch is trying to do right now. And they've already done tests and things like that with Ursa Major, the engine provider. So it looks good. So we'll have to see. AN-225 was designed in mind to transport and launch the Buran. Yes, and in fact, wait, didn't it? Or did it never actually do that? Did it actually never? No, it did. Yeah, okay. I mean, Buran never, yeah, only flew the one time, but yeah, it did, right? The AN Antonov did do a thing. Oh, Wikipedia, hello. Yeah, there you go. Ooh, it's nice. Yeah. The Antonov, very nice. Very nice indeed. But this is not a air launch platform, sadly. All right, chat. Let's go ahead and start getting our stuff here ready. So like I said, we redid our PID control loop here, all of our code. Almost, I mean, yeah, pretty much worked it from, you know, reworked it from the ground up. What I would like to see... So that's going to be the result outputs. That's all fine, because that'll be proportional. It would probably be good. So that's going to be the overall output. I wonder if it would be good to do just the error. Print. Actually, you know what? Let's do that with respect to the PID output, I think. Yeah. So PID output like that. Gosh, how do you do multiple things? Can you just do a plus here? I think you can, right? Is it like that? Yeah, okay, cool. So then that, and then we want to do this. Error. And then we can do %F. Can't you do like .2 or is it .2F? We'll just do F. Or do I have it? I have it in another code here that we're printing out. I just saw it. There it is. So yeah, .2F. Okay. Okay. I can do it like that as well. Printing. Yeah. Okay, that's fine. Yeah, we'll just do the error itself. That's actually going to be fine. So can I do self dot error? Oh, I can't do that unless I actually do the F up front, so that's fine. We'll just do it as is. Self dot error. Last error, yeah. Okay, because then that should run on the output and that should be fine. So debug itself should be a flag, right? Oh no, I have to call it. Okay, cool. Sounds good. That was why I had it 2 tail fins on the horizontal stabilizer. Yeah, indeed. Yeah, the Antonov system was quite chonkers. Maybe like a small solid rocket booster like the Russian ground-based ballistic missiles that have small stage that detaches shortly after launching to reveal a ramjet might work. Oh, you're talking about for the air launch system? Gotcha. A problem with air launch, you cannot recycle fuel or keep fuel cold mid-launch. Yeah, that is also a fair point, Jan, from an operations standpoint, yeah. Like if you guys were following the old days of Pegasus, or even Virgin Orbit, right? They had to basically fuel their rocket up on the ground, manage the pressure, manage the boil off, and then during the entire flight up to 30,000 feet or whatever it was for them to launch, however long that took, they couldn't actually continue topping off the cryogens. So you either don't use cryogens and suffer performance, or you figure out how to maybe push cryogens into your system, which means you have to have cryogen tanks on your plane, which, you know, yeah, fueling a rocket is a dynamic state. It's not great. There's a lot of things that can go wrong when you're fueling a rocket. So, yeah. So that all looks good. So what I want to do here, chat, is because we changed our code here, we have all of these PID loops that have now essentially changed as well. So I think what I would like to do, let's go ahead and cut all of this for the moment, because I really want this to be very, very simple. We're going to make this 1, 0, 0. So only proportion of just a constant 1. That should be fine there. And then we'll do that for the altitude controller as well, because I want to see just how far off. And then the slam controller, I actually don't care about that right now. 5 is probably going to be potentially too much, but we'll see. So I want to test one thing at a time. So this is our vertical altitude hold controller, if I'm not mistaken. Yeah, so we have our altitude hold, and so we also want to probably test that. So let's do that for 10 seconds and see how well that does. We can even actually do that for longer. And then let's go up to a certain altitude, and that altitude will be not 68,000. Let's do it up to 2,000 here, and that should be fine. What is TU? Those are just constants. I think this is, if I remember correctly, Nichols-Ziegler method, which is basically a way to calculate a good, I guess, starting point for your PID gains, right? The TU, KU are constants, and then you basically tune these, and your PID stay roughly the same ratio, I guess is the proper term for it. All right, that all looks fine and dandy. So we're going up to 2,000. We're going to try to do an altitude hold for 10 seconds. And let's just see if it even runs, chat, because we have changed some things around. So stand by. A required landing to deal with. Oof, Jan, yeah. All right, here we go. 2, 1. And we're away. Build a large rotor platform with tank farm. Yeah, that'll do it. Slightly confused with that. What are you confused about? All right, so we should be going up to around 2,000. It's now coasting up to 2,000. And there we go, almost on the money. Ah, that's actually not too bad, huh? Looks like we're gonna need a little bit of an integral term. So what are we doing now? Now we're working with the slam controller. Slam controller. Ooh, yeah. The slam controller is definitely way overcompensating, chat. At least I think it's on its slam controller, is it not? Is it on its altitude hold still? No, it's definitely in mode 3. Mode 3 should be descending at 5 meters per second, and we are definitely not descending at 5 meters per second. It is at 5, set to 5, right? It's a good thing we have a lot of fuel right now, chat. see, set point 5 meter, negative 5 meters per second. I think maybe, yeah, set point altitude negative 5. So it should be, yeah, it should be set point of negative 5 that determines that. Okay, well, let's land it and we'll run it again. There we go. Hey, what's up, YouTube? How are you doing? Hope you're doing swell. All right, tease it. Tease it. That sunset hue, yes, not too bad, right? Not too bad. Are you saying that your gains are in dependent form because it looked like they are in independent form? Yes, that's correct. Stand by. No, are you saying dependent on each other? They basically are a set value or ratio with respect to each other, and then you tune one parameter, that ratio, and then it changes them all to be relative to that ratio. That's essentially how I have it set up, which I think, if I recall correctly, it's been a minute, is the Nichols-Ziegler method. Here, I'll show you. So here's another way to do it. So you set your constants, which go into the definition of KP, KI, and KD, right? So for example, KI is 2 times KP divided by this constant of TU. And so you can change these values depending upon how much effect that you actually want to have on the rest of your proportional, integral, and derivative gains. I don't know. That's old. It's been a minute since we wrote this, so I don't remember. I don't actually remember where this came from. But I'm pretty sure that was Nichols-Ziegler method. Yeah, dependent form. All right, so that all worked pretty well, if I do say so. There's a couple things that we're gonna have to change though. Let me see. How do I have my altitude hold set up right now? So I have my vertical velocity set point is going to be equivalent to our altitude controller set point, or I should say output. And our altitude controller is going to be set to the tilim.apoapsis at that point. So what is it doing here? Because we have vertical set point is altitude controller, and altitude controller set point is -5. Yeah. So if that's saying that it wants to have an altitude of -5 meters, it's not doing that. It's not going down, chat. So we're going to have to change these values here. Like I said, I probably want to actually get rid of this and just simplify these if I can. And let's just start with 1, 0, 0, make it easier, kind of decouple everything. And then we have our horizontal velocity controller. That we can maybe do the same as well, but anyways, let's also go back up here. I wanted to add a little bit of an integral term, a very small amount. Everything seemed to work pretty well on our controllers up here. Let's do a very small, very small integral term on both here, because it looked like we had a steady state error. So for those who don't know anything about linear controls like PIDs, your proportional term essentially dictates how fast your system will respond to a given input error. But that doesn't necessarily mean, depending on your system, that you're going to achieve 0 error. It's just the vehicle will try to compensate for an error, but you may never actually achieve your desired endpoint. So you actually will add then your I term, or the integral term, which means that your vehicle, you're basically integrating the error over time. So if you have even a small error over a large number of time steps, that means that your output from your PID is going to get larger and larger to try to compensate for it, to try and drive the error to 0. So that's why we're going to add a very, very small I term in our system. All right, let's go ahead and refuel it and see what we got. Can you paste it into pastebin? It's on, oh no, it's not. Okay, here, stand by. In a paste bin. You know, I've never actually used Pastebin, or at least I don't use it very often. Is it easy? I suppose. Bum, 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 bum. Yeah, you know what? I've never used a Pastebin before. Never had to. Oh, create new paste. Okay, there we go. Cool. That was not so hard, just had to find the right button. Is TWR used as well? No, TWR is not directly used. The throttle is essentially trying to, it's changing throttle to try and achieve a desired, essentially, altitude. So if our altitude is exactly, if our current altitude is where our desired altitude is, it will then change the actual thrust to try and to basically stay there. So no, I don't think it's actually using TWR specifically. All right, so let's go ahead and try that again. Quick test iteration here. There we go. Oh dear. I hate it when it does that, chat. I don't know why it for whatever reason, after like landing, something about KRPC or the game or something just completely completely messes everything up from KRPC standpoint, which is kind of funny. I don't really get it. I don't know why. I don't know why it does that. All right, let's try this again. This time I'll make sure to F5 before launch. But yeah, I don't know why it does that. I don't know if like KSP, yeah, after landing, it just always takes a hard right turn like Astra's flight. I don't know if it's like control point that it's trying to find or something. It's weird. That's your standard launch profile. Hey, there you go. Hey, teach their own, I suppose, right? Go ahead and put these traverse rates up a little bit. There we go. Okay. What GPU do I run? I think it's a 2070. There we go. And there we go. Okay, let's try this again, yeah? Go ahead and refuel it. Go ahead and F5. There we go. Oh, you want the DCX simple test? Gotcha. Yeah, that code's a little bit more of a mess. There you go. All right. So let's go ahead and see what happens here. So we added a little bit of an integral term, so that should be fine. Yeah, very small integral term. Let's go ahead and fly it, see what happens. We'll go ahead and F5 again, just in case. Did that actually F5? Hello, game, thank you. And run it. So, you know, the good news is, chat, actually, the PID system at least works, right? Now I think it's just a matter of of tuning it. Yeah, it's just a matter of tuning the controllers now with the new form. So that's good. Nothing at least really broke, as far as I can tell so far. There we go. And there we go. So there's altitude hold, looks good. Oh, that's very stable. Wow. That's super stable, chat. It's trying to catch to the pad now. That slam controller is very temperamental. Oh, no, wait, we're still in 2A. Okay. Well, that's better, actually. You see that, chat? We're now actually descending at 5 meters per second thereabout. So that is better, but our 2A controller, our 2A mode is not doing as good. Okay, let me go ahead and shut that off for a second, and let's land and see if we can't go back in the logs here and check it out. Actually, I don't know why I'm doing this. Just quick save. Quick load. All right, let's see. I think it was 2A I saw in the readouts. Yeah, 2A. It goes from 2A briefly. Oh, no, it doesn't even go through 2B. Okay, cool. So 2A, it's doing something with the slam controller. So let's now work on the slam controller because we have it basically set at 5. So, you know, that could probably definitely come down. We are capping it at 1, deadband 005. I don't even think it needs a deadband, but whatever. Slam controller set point. What is that set point? What is the slam controller actually trying to do? Is that... Yeah, what is the slam controller using in its calculations? Time to burn. Oh, okay. So it starts its burn slightly before hitting 0. Okay, so it basically starts the burn right before hitting time to burn equals 0. Okay, that's fine then. But then... And then we're setting the throttle equal to that because we were always trying to keep our time to burn near 0. So if we actually go higher in throttle, that means our time to burn starts increasing beyond, you know, above 0 because we're over throttling and it's not compensating for that there. So that was fine. Did see some oscillations on the other controllers, but for the most part, I want to continue making sure that we at least get the functionality in and then we can start optimizing. So yeah, let's run it back. Let's also change it from T-10 so we don't have to wait 10 seconds every time. And we'll do T-1. There we go. Hey, Sea-Kraken, how's it going? And Smoke, hope you guys are doing good. And Oddly Tugs, how are you? Oh gosh, see, I don't know what it is, chat. Every time, wow, we jumped over that, didn't we? Okay. I don't know why, chat, but for whatever reason, every time you land, the game changes something, and I don't understand why. But anyways, we're fine. Everything is fine. It righted itself. A close one indeed. It skipped right over the propellant farm, the propellant tanks. Not great. Not great. But anyways. Yep, looking to hit that 2-kilometer mark. I'm really glad that our predictor is... It's pretty close to being dead on balls accurate. It's an industry term. Let's see if I can't null this rate out a little bit here. There we go. Yeah, that seemed actually pretty good. So now it's going to try to track the pad. Of course, it's not going to actually be able to here, but that's fine. Yeah, that slam controller is still... Well... Actually, that looks a whole lot better, doesn't it, chat? All right, so that controller is a little bit much, chat. If I do say so. That is going to be mode 3, so I'm pretty sure that's what we just changed. Oh no. Stand by. So that's going to be mode 3. Let's go ahead and shut that off, and let's go ahead and land it. That's it. That's the independent form? Is it really? Gotcha. What defines independent versus dependent? Oops, there we go. Had unusual burn off. Yeah, a little bit, didn't it? Yeah, a little bit. All right, let's go ahead and fill it back up. There we go. Perfect. I really wish I knew why it just goes sideways, but anyways, chat. So that was this controller here. We had a vertical velocity controller change, and then we don't actually update the altitude controller, do we? We don't. Vertical velocity controller is set to 1. What happens if we just change that to 0.1? Again, just testing things here. Stop it, stop it, stop it, stop it, stop it, stop. That was me taking manual control again. Trying to keep it from... There we go. Go straight up, please. Thank you. It actually won't go straight up. It'll go slightly off. But, yeah, it's fine. It does this to make sure it gets away from the pad when we actually do, like, a suborbital hop. Do a backflip. I know, right? I feel like I haven't seen you in ages? How long has it been? I mean, we streamed Monday. And then Wednesday, my normal stream time, Rocket Gal had an event that I had to we went together with, and then may have gotten sick from that, so I've been kind of down the last couple days. And now we're back. Vertical-ish takeoff, yeah, something like that. So now it does a belly flop, gets into its orientation. I don't know why it does that. Okay, not bad. It's doing this because it's trying to get back to the takeoff point, so that's nominal. All right. Well, that did it, actually. Huh. So now, in that case, chat, you know what it is? It's the actual SLAM controller calculations. At least for this altitude, maybe. I wonder if it would actually do the same if we did a large suborbital hop. Because we have our SLAM calculator. And by SLAM, I mean hover SLAM, of course. SLAM controller. We're calculating our burn, burn start. And we're updating that where? I think it's on the outside, yeah. We have that SLAM controller, we get the TB, and that TB is, of course, calculated previously up here on calculate landing burn vessel. Yeah, it's from here. Are you gonna land there, bud? You got 1,000 meters per second delta V. Oh, look at that. We actually have a steady state error over time, chat. We do. We have a steady state error. So I might need a very small amount of integral term here as well. It is dynamically changing the throttle, though. You see that? It is lowering the throttle here, trying to compensate. That's good. But you know what? I would like for this to land. Please. Thank you. There we go. Get it on the ground. Get it on the ground. Okay. So it actually might have to do with our hover SLAM calculation. Because that, I mean, this calculation is correct. It's just, is it accounting for the vehicle in a good way. Time to burn, either that or we need to give our time to burn a slightly larger change, slightly larger set point as well. So I think I use 95% throttle, and then we are trying to calculate based off of our height, target stopping altitude, but our altitude, oh, that's actually, what altitude is this? Because we're stopping way above it, so it doesn't really even matter whether or not it's the sea level altitude. Yeah. So that's H infinity, which is based off of our engine offset and our surface altitude. HT times G. If we really wanted to update this, well, we should actually add a drag term to this as well. It's fine. It's fine for now. The other thing that we can do, like I said, is change our time to burn and have it burn later. That's another way we can do it as well. Or we can actually also have it based off of altitude. Time to burn, and then depending on how that goes, there's ways to do it. I'm actually more curious to see how it flies going really, really high, because it's going to come down much, much faster. And so I'm wondering if the current controller is more tuned to that right now. I didn't know you had to bring a heat shield with you when going to Eve. I wouldn't success. Yeah. Yeah, you kind of need a heat shield for sure. You definitely need a heat shield. So if you wanted to use the dependent form, you'd be calling it with 0 KP KIKD. Gotcha. So instead of defining those constants and stuff. Or are you talking about how I have the actual PID.py set up? Yeah, I think it's this update TB, and our TB it's greater than negative 0.75. Yeah, I'd have to actually, I guess, output that and see if it works. Either that or we can just change our SLAM controller and see if that works even better. Because our SLAM controller is essentially our, yeah, let's actually change this to 0.1, and let's add a very, very small integral term as well. Yeah, 0.01. It actually might be probably way too much integral term, but that's fine for now. That all we know works. So this works, even if it's a little bit much. Oops. It kind of changes the throttle a little bit too fast, so we'll bring that down as well. We'll definitely bring that down. Horizontal velocity might be fine. Haven't really seen that kick in yet. And yeah, it's just the SLAM controller and that thing. Okay. Well, let's try it one more time. And like I said, at least this test has been good because we know that the vehicle and the PID control systems that I changed work. And that is key, chat. That is key. All right, so here we go. One more test and let's see what happens. Do you, uh-oh, I forgot about that. I forgot about it. No, stop it. Oh, well. Do you automate orbit operations too, or only launch and landing? Currently launch and landing. I do want to get into full automation though. We're doing it step by step, right? We do launch all the way through MECO and then second stage into its parking orbits. We do first stage landing. Yeah. And I have codes probably that could work right now for like doing automated Hohmann transfers and stuff, but they're not tied into anything yet. All right, let's try this again. As is. Boop. Have you played the game Rocket League? Come on, there we go. Tease it. I know of Rocket League. I have not played Rocket League in, gosh, years. Many years. in fact. Probably like since the game came out. I liked it. It was fun. Just wasn't for me, you know? All right, coasting up. That's actually really good. It does have an overshoot, but then it just locks in, and that's nice. So yeah, we're at our altitude hold. Very, very slight, but deviation, but I think that's fine. Now it tries to track the pad, but then it's gotta get into its landing mode. Oh, that seems a little bit better. Potentially. Maybe not. Might be a little bit slow. It's a little bit slow, chat. I think it's a little bit slow. It's a little bit slow. All right, so that was too much. That was too little, chat. Yeah, that was a little slow there. A little slow on the get-go. So yeah, that's a little not fast enough, chat. Not fast enough. We changed the. I don't know if we didn't change this though, did we? Oh no, it's not that one. That was the problem. It was our time to burn. It was our slam controller. Our slam controller was set to 5, and then we changed it to 0.1. So yeah, let's just change it to 1 with a little bit of an integral term there, and see what happens. That was a little much. Hey, what's up, own sister? How are you? Hey, awesome, Bone Sister. That's cool, man. Any idea if you're gonna base it off of KSP maneuver nodes or try to do something crazy for maneuver planning? Probably do it incrementally, Tyler. Probably start with maneuver nodes. But honestly, what I kind of envision is being able to have a basically a command line interface where I can say, hey, you know, go to this altitude, and have it then execute that based off of the optimal home and transfer to get there, right? Home and transfers are easy because you should start basically in a circular orbit or near circular, and you're trying to go to another circular orbit, right? But there could be definitely a lot more challenging things to implement. A much wider, diverse set of maneuvers that can be implemented if you do it that way. Alrighty then. Or you know what? We might just go straight to that, you know? Yay for kabooms! Yes, very good. All right, so we changed that back to 1 with a very small integral term. Let's go ahead and run that. Stab it. I don't know why it does that, chat. But for whatever reason after landing, it always wants to do that. But nah, whatever. It's something to do with the game. Whatever. Double it and give it to the next PID controller. There you go. Exactly. Exactly. Hey, weather guy. What's good? How are you doing? Yep. Oh, that's actually a really nice response. Did you see that, chat? I like that. Does this give me... It does give me climb rate. I want to look at that next time. See just how far off we are. It's pretty good though. Like I'm not worried about that. Okay, it's looking good. So we're still in mode 2A. That's at like 95% throttle. That's actually really pretty nice. Okay. I wonder if I should have a slightly... Yeah, what is our climb rate? -2. What do we have there? Set as our controller. Because that's going to be... it should be descending at about 5 meters per second. It's descending at 2 and opening. So do we only have a proportional implemented right now? Because that's going to be on... Oh, we do only have proportional. Aha. Okay, good to know. Let's actually go ahead and increase this up a little bit as well. And let's give it a small integral term. And then we'll reset here. Yeah, I definitely want to see the error GUI data on the altitude hold and see how far that's off. It looks like we're getting pretty good responses there. But the maneuver planning felt like a tricky one to get. It definitely can be. Maneuver nodes would certainly be a way to simplify things. Hey, what's up, Bacon? How are you doing? Hope you're doing well. You have a mod pack that adds Dune. You probably meant Duna. Maybe autocorrect, but if you do have Dune, that's pretty cool if there is a mod for that. It wouldn't surprise me, I suppose. All right, let's try it again. Stand by for the gigantic shot. Stop it. Oh, man, chat. Like I said, I don't know why this vehicle does it after landing. Was something that KSP or KRPC does. Just puts that in. It's weird. Very weird, very strange. And annoying, quite frankly. And annoying. I forgot the not Mars name. Yeah, Duna. You meant Duna. You got everyone in Twitch. Hoping there was a mod for that now. All right, there we go. That went better. Still kind of slid off the pad a bit, but oh well. All right, going up to 2 kilometers altitude. Altitude hold for 10 seconds, and then yeah, then we'll see what happens. Proton M roleplay. What game is this? Kerbal Space Program, also known as KSP. Kerbal Space Program. There we go. Oh, that's actually really good. Oh, and look at the climb rate. Now it's going back up. Okay. I was hoping that it was going, it's maintaining. It's maintaining. It's fluctuating a little bit. But that's pretty good. I'm happy with that. Better than KSP2? Yeah. Unfortunately so. Oh, chat, that's the horizontal velocity controller. It's trying to null out the horizontal velocity. That's nice. I'm wondering if that is playing into this. Because it's trying to pitch, and because it's pitching, it's changing. Maybe. Yeah, I don't know why. It's a little bit slow on the response. And it's definitely still not, because we do have it set to -5 for that. Set point, vertical velocity set point. Yeah, because we have it set on the altitude controller. And the altitude controller should be trying to get to -5. See, it is starting to increase, but very, very slowly. Does it just need... It's trying to get back to the pad, chat. The climb rate is much slower, though. Does it need a higher integral term, I wonder? I wonder if I need to output, what is the altitude controller? Because if, like, the altitude controller is constantly, you know, high, but then the vertical velocity controller is not compensating for that. I'm wondering. But hey, look at that, chat. Not bad. All right, let's see here. And I'm also wondering, is it the vertical velocity controller that we need to change, or is it actually the altitude controller? Because the altitude controller is what defines the target of our vertical velocity controller, right? So I am wondering, and where do we define this as? Yeah. No, that's not the definition. That's the set point. Yeah, because we have that set point as tilim.apoapsis, so that's fine. New throttle limit. Oh, is it our throttle limit? Do I update that? Stand by. Is that down here at all anywhere? Well, mode never is 5. So no, it shouldn't be. I wouldn't mind, I guess, getting rid of all of this, though. If they're not actually helping. Wait, where's throttle update? Oh, it's up here. Gotcha. Okay. So it checks every 5 seconds roughly to see if the throttle needs to be set to a new minimum. But if we're never actually doing that, let's actually just take that out just to make sure that we're good here. Okay. But I don't think that's going to actually fix the problem that we're having. We could always print out the altitude controller. Let's actually do that because I'm curious. So let's go ahead and, oops, not there. Let's go ahead and print. Actually, I guess we can do it down here where I'm already printing things. Yeah. So I want to print the vertical velocity controller dot set point. Yeah. Okay, so we'll call that, and we're gonna go ahead and refuel, and we'll test it again. All right, let's run it back. Hey, what's up, Terrace? How are you? Oh, wow. For whatever reason, that took off perfectly that time. What is best landing accuracy? Currently 22 meters. 22 meters from the pinpoint spot that I want it to be. Right now, we that was achieved last stream, this past Monday. Now we have updated our controller, and now we're going back and testing the control architecture, making sure everything is still working after the changes. And then if I can confirm that it's all good and working, then we can start tuning it for the other vehicle and start testing that vehicle, getting that back to the point where it should be, see if its accuracy has improved, and then get into some more robust control systems and whatnot for even better accuracy. But baby steps, so step at a time, incremental improvement, right? Okay, that looks good. Yeah, I like this control response here. All right, so where are we at? -2. We're staying at -2. Interesting. Okay, so what's our output look like? Ah, there you go, chat. So that's why. Well, no. Because our altitude control, it's basically saying, yeah, it's basically saying that it's trying to target -3 meters. I guess I just need to have a larger, either I need to have a larger negative value for our target altitude, because it technically is working. It's just not quite what I'm actually wanting here. But yeah, I mean, like the throttle and everything is working, which is fine. But the altitude, okay, not bad. So the altitude set point is still saying negative, which is fine. Yeah, you know what? I'm curious. If I do set this to say 10, and then set this, so that's going to be -10, set min output -10. Yeah, I want to see if setting the set point to -10, how is the altitude controller actually defining that output here? That's what I'm curious. That's what I'm curious here. Hard landing for those crew members. Yeah, no kidding, right? Can this land from 140 kilometers altitude? We haven't tested that. Unfortunately, this thing doesn't have enough propellant to get it up to 140. It can only go up to 78, and we have tested it from 78, and it can come back down, and it will land within this hexagon here. So it does do that. It'll go up to 78 kilometers, come back, track the pad, and land here, which I will do a test of that here at some point, once we make sure the controller is looking good. Right now it's doing its altitude hold. Now it's tracking the pad, aiming for the pad. It won't really have much of a chance though, because it'll start to turn vertical. Yeah, good throttle. Like, that's really, really smooth. SN8 vibes? Yeah, you're not wrong. Okay, null out the horizontal velocity. There we go. Verticate. All right, so what is it actually set to right now? -4, -5, and is that changing the climb rate? It's not actually changing the climb rate. What is our vertical velocity then? Because this should be our vertical velocity set point, and it's not achieving that. So either we do need a higher gain on our vertical velocity controller, or this is not working how I'm thinking it should work. Because this is basically saying, so our vertical velocity controller, right, is managing our throttle. And it's trying to manage that throttle to achieve, at this point, -3 meters per second descent rate. So either we're not using the actually correct, I think we are though, value, or our controller just is unfortunately not, we need, I guess, a higher integral term or something like that for it to be able to respond faster. We will get to that, whatever. But that's not what I'm testing right now. Good enough, catch it? Yeah, I know, right? So we're at -2.7. You know what? Let's land it, recycle. And let's actually increase our integral term in our vertical velocity controller and see if that helps. So we'll increase it by an order of magnitude here and see if that just makes it go completely haywire. or if that actually does help it respond. Also, with respect to the controller, the minimum, I think I actually might want to make that -5. And we'll see what we can do here. Those are always pretty conservative values anyways. Horizontal velocity controller, I'd have to test that as well. But one thing at a time, I suppose. All right, run it back. See, I don't know why, chat. I don't know what's changed, but now the vehicle just goes straight up right on launch, even though we're F9ing and whatnot, quick loading. And how do you do it, by the way, Rams? Yeah, if you're just coming in, we are testing. I over the last couple of days, while I've been a little under the weather, I redid our PID control Python code. Changing its design to be what's known as velocity based, the velocity form, which instead of using the error itself, you use the change in error. It can help smooth out the control inputs and things like that. And so now we are trying to test and verify that the code that I completely redid is working as intended. Yep, looking good. Oh, there we go. That's better. Oh, that's actually super good. Okay, there we go. Look at that, chat. Driving that to match this. Oh, yeah. Yeah, nice. I like it. What is our set point? -10, right? Yeah, it's -10. Cool. Whoops. There we go. Loop tuning is an art. Yeah, no kidding, right? And touchdown. Hell yeah, chat. Awesome. All right, well that's pretty good. Much easier with graphs. Yeah, it's true. We could plot everything and whatnot, but yeah. I just like flying it. To me, that's the more entertaining way of tuning these PIDs, since we have the luxury of such a fantastic simulation environment, right? Which is just launch it. All right, so that worked pretty well. The other thing I actually want to test here is the horizontal velocity controller. We have a horizontal velocity controller to try and null out the rates of the vehicle coming in sideways. So I want to see if that is now up for improvement. So we have a set point of 0. Let's give it a little bit more integral term now, because it doesn't look like it was actually doing too much. We have a small amount of derivative controller as well that might need to be increased. Let's go 10 and -10, so that way the vehicle, we can actually see the vehicle turning, right? And yeah, let's just do that. Why not? All right. We'll do a live, that's right. Yeah, great meme. 10 out of 10. All right, looking good, looking good. Come on, there we go. Keep an eye on our climb rate here once we get up to apoapsis. Because it should be, you know, between 0 and 1. Ideally close to a 0. Yep, and it's starting to wind down as well. I'm happy with that. That's pretty good for an altitude hold. When's the next mission to Minmus? I know. As soon as I want to do that. I'm on this this desire to get our first stage reusable, and then we'll get back into some more mission mode stuff. That's kind of what I'm thinking, anyways. So right now it's tracking the pad, which is why it's trying to go this way. And then it hits its altitude target, and then we'll verticate. And then it should essentially try to null out its velocity. There it goes. Hey, look at that, chat. Nice. Climb rate is -5. Cool. So yeah, now we can start looking at our calculator for our time to burn. So time to burn, it's a little bit conservative, right? And we do that up here. Steering, time to burn, vessel. And this works. I'm using the analytical form to calculate our hover slam, which essentially means, chat, that it doesn't account for drag. It doesn't account for drag on the vehicle. And it doesn't account for some other things as well. We have 95% throttle indicator there. It's all based on our vehicle mass. Yeah, we should be trying to stop at a target altitude of 20, but it's it's not. I wonder what that engine offset is. Actually. Because the time to burn, I mean, it's clearly working, but our desired stopping point is not correct. And I don't know if that's just because it is the analytical form, and analytical solutions are always going to be inaccurate in comparison to actually running like an estimator in a separate thread and whatnot. Hey, there you go, Kazlo. What's good, man? It'd be cool to output to limb from the control system and graph in a local Grafana instance. Man, that would be awesome. Hey, if that's what you want to do, I'm down. I'd do it. I'd use it. So we're calculating based on our velocity and our current difference in our altitude. And how are we calculating this? H infinity. Yeah, we're calculating H infinity relative to our surface altitude, but then plus engine offset. No, that should be right. I think that should be right. Our engine offset should be with respect to our vessel reference frame, right? Vessel reference frame, vessel reference frame. These are the docs for KRPC, the mod that we're using. If we go to vessel, is it in vessel? No, it's in flight, right? It's in flight. And if we scroll down, is it not? Is it in vessel? Ah, it is in vessel. Okay, reference frame. The reference frame that is fixed relative to the vessel and oriented with the vessel. Yeah, okay. So X points out on the right, Y points in the direction, forward direction of the vessel, and Z axis points out of the bottom of the vessel from, yeah, axis down, okay. So that should be right. So the engine offset should be calculated correctly. So for a second, I was wondering if this was basically adding our surface altitude again to it, which is why we're, you know, so high, but it's not true. The answer is 42. Ah, yes, yes, indeed. Yes, indeed, my friend. Yes, yes, very good. That's our flight path angle, sine of our Should be right. Get flight path angle. It's in our surface frame. And then we take the dot product of RV divided by R mag. That should be right. And it's our position, which is going to be, yeah, okay. It's going to be a tuple in the surface reference frame. Okay. I think that should be correct. Again, I'm just trying to make sure. You know, I guess the easiest way to do it is just to print things out from here, right? So I guess we'll just do that. So we'll go ahead and print. This is going to be burn calculator values. Yeah, you have to do the F up front. No, steering logic. There we go. Burn calculator values. Actually, you know what? Let's just not do that. So we're going to have H infinity being H infinity. There we go. And then we are going to have our HT. Well, HT is always going to be constant, right? So we don't really care about that. Flight path angle. I am interested in seeing what that's going to be, because that should be in radians. I'm not really worried about that. And that's going to be with respect to the surface frame. Orbit.body.reference frame. So it's going to be relative to the surface of our body that we're orbiting around. In this case, Kerbin. Is it in celestial body? Yeah, it's in celestial body. Hey, what's up, Houston? How are you doing? So over the past few days, Houston, I rewrote the PID control loop code and reorganized it to be the delta error form or the velocity form of PID. And so now we're going through and making sure that everything still works despite changing all of that code around. So that's why. What have you been doing in KSP? I've been working on my Scratch game the whole time while I watch you play KSP, but what have you been doing so far? A lot of flight testing. A lot of flight testing. All right, so we're in the reference frame, orbit body reference frame. The origin is at the center of the body. The axes rotate with the body, and the x-axis points out of the center. Okay. I think that's fine. We get the position in that reference frame, the velocity in that reference frame. And that's our flight path angle. Yeah. Yeah, I'll have to go through this and look a little bit more at it. And then that's all just, okay. So then I want to know what TB is. So I'm interested in understanding what it's using as H infinity and then what it's using actually as the time to burn, which is TB. So that's going to be TB.2F. Okay. So let's just go ahead and rerun the system here after quick load and see what we got. Because our time to burn... Yeah, our time to burn, we can also look at ATG. Yeah, we can also look at that as well. Because that's our acceleration to go. Basically, it's our acceleration with respect to our thrust. Yeah. Okay. Yeah, fair enough. That, I think, should work. We also had that one. Calculate landing burn time. And what are we using up here? Calculate landing burn time. Yeah, we were also using calculate landing burn a while ago as well, which is very similar, but it's a little bit different. For this one, instead of calculating our time to burn, we actually basically start our burn whenever our thrust is equal to our calculated thrust. Whenever our maximum thrust value is the same as how much thrust we need to actually implement the hover slam. So it's slightly different. It's pretty much the same thing though. Okay, yeah, let's see what that does. I'm curious, chat. The answer is 154, make one be, yeah. Also that, also that. So that should have run. Oh, I'm in the wrong thing. Here we go. Okay, let's see what happens, chat. There we go. Takeoff is clean, looking good. We'll get up here to 2 kilometers. There it goes. It'll now coast. Yeah, I think after this, we'll start doing an envelope expansion test and maybe take it up to, say, like 10,000 meters, 10 kilometers altitude. And have it really test the belly flop and tracking again. That might be good. Okay. So right now it says our H infinity is 1400. Aha! Well, 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 chat. So is it actually doing what I'm thinking it's doing? What I was originally thinking it was doing? Surface altitude. What does it think its surface altitude is? Are we in the wrong reference frame? Are we in the wrong no. Maybe. Surface frame. Wait a second. Orbit.body.reference frame. But the wait a second. Fixed relative to the celestial body. The origin is at the center of the body. So we have vessel.flight dot surface altitude. No, they should. What the heck? What the heck? Yeah, sorry, I was actually looking at the wrong thing anyways. Okay. Woo. For a second there, chat. for a second there. You know what? I should also check V infinity as well, just to make sure, but all right, so but yeah, our H infinity is 493. Right? That is where our H infinity is. Yeah. It's 493. Wait. Was I just looking at the wrong thing? Hold up. Was I not? Did it not say over 1,000? Was I looking at the wrong thing or something? No. No, I'm sorry. Stop that. Am I crazy, chat? Was it not at like 1,400 or something like that? Or did I just look at the wrong line or something? It got updated later? It did do that, right? Lag in the data log. That's wild if that's actually what happened. Okay, let's run that again. You saw when it changed? Yeah. Ah, every time, chat, wrong line. There we go. So is that why something is, uh-oh. It's doing the weird thing, chat. There we go. Sometimes it does that. I don't know why. All right. Erudite, I blame you. Erudite came in and said hello, and then explosion. What's up, Cletus? How are you? Run it back, chat. Run it back. Yeah, if that happens again, I'd be very curious. Doing pretty good. No complaints. No complaints. Getting on the up and up. What? Okay, there we go. There we go. Nope, stop it. Thank you. A perfectly nominal launch. Yeah, fair enough. Blame the Kraken. I definitely blame the Kraken, yeah. Is the backslash doing something? You'll have to be more specific. Backslash? I have to pay for the damages? You do have to pay for the damages, yeah, 100%. Altitude hold still looks good. All this is still looking good, so yeah, it's just so everything is working well. It's just retuning the controllers, retuning the gains rather. All right, and pause. 1400 is what we're at right now. It says 1825. No, 1428. Okay. Then that's correct. Right? And that's definitely correct. $900. No, that's definitely right. Time to burn, though, is not being kept at the value it should be. But no, that was right. And it's H infinity. Yeah, interesting. Gosh dang it. Why are you like this game? Alright, I'm gonna comment these out because I don't care about these at the moment. We're gonna run it back real quick just from, yeah, no, we'll just quick load. I'm gonna do that one more time just for repeatability. That's so weird. that's so strange. But it's also, what do I have my set point? Because right now, it looks like it stopped at set point 0.4, and it was bringing it down, but it stopped. It went really, it overshot, right? Dun, dun. So slam controller. Oh, it is supposed to be 0.5. Okay. It overshot though, didn't it? Like a lot? Or am I crazy? 0.76. Yeah, I wonder if slam controller set point should actually be... I want to try 0 and see what that does. That basically means that our time to burn should always be at the latest time possible, right? You don't want it to be negative because then that means you don't burn. So you always want it to burn. So 0 would technically, like, setting it to 0 should theoretically mean that you start your burn at the exact instant that's required for you to basically have 0 vertical velocity when you're touching the ground. So, you know, we were testing it with 0.5 to make sure that we gave ourselves a little bit of, you know, breathing room to make sure we're not doing such a close call, but maybe we were doing too close of a call, chat. Wondering if it actually needs a little bit more, integral as well. Might be lurking today. Hey, understandable. All right, let's run it back with that little change there. See what's good. So now we shouldn't get any printouts other than just our altitude. Is there any ramp up time? I mean, there's some, clearly, because it takes a second for the controller to react to the error, right? Like, in terms of PIDs, there's no such thing as an instantaneous implementation for your control input. It always lags a little bit because it needs to calculate the difference in error in your time step, right? But it shouldn't, it's not, you saw it there, right? It went, right? So it's a pretty fast reaction. But yeah, there is a ramp up time, but on the order of milliseconds, I would assume. All right, that's working. Yeah, that's working for sure. That was the problem, chat. I gave myself with the new controller design, I gave myself too much room. Yeah, gave myself too much room. I was way too conservative. The 0.5 time to burn was fine for a margin using the old controller design, but not this new controller design. So that's interesting, chat. That's actually pretty cool. Pretty cool to see. So we want our set time for our slam to maybe be 0.05, so we give ourselves a little bit. And let's try that now. Yeah, that works super. That was really clean, actually. Yeah, 100%. Yeah, that was really, really clean. Real quick, chat, on the Twitch side, if you are new to the stream, I do run manual ads, typically every hour, to try and get rid of all of the Twitch injected ads that they now do. So we're gonna be right back. Don't worry, you're not gonna miss the launch. I'm just gonna kind of basically pause the stream and talk to anybody who doesn't get ads, I guess. But yeah, you guys will be back, and then we'll launch and we'll see how this goes. So I'll see you guys back here in a few. What's up, Gunslinger? How are you doing? I guess Twitch has more people talking, so you haven't seen it. Seen what? Mm-hmm. Yeah, that actually worked really, really clean. Really clean indeed. Yep, so we're just gonna chill out here for a moment here while Twitch goes through a quick ad break. So this is to make fully reusable rockets like Falcon 9 to save money in hardcore. That's right, Blurgert. That's exactly right. I've been trying to tell you where the backslash is. I am not seeing anything. Here's my YouTube chat. This was your last post. I don't know. I don't know what to tell you. This is all I'm seeing here from you, bud. I don't know why. I don't know if you've been more, unless you're going through a different medium. Are you talking somewhere else? But yeah, no, this is, I only see these couple of posts. Maybe they mean they put it in Twitch. Not on the Twitch side that I can see, anyways. Unless I miss something further up. No, last thing I see is we'll do it live before then. So I don't know. I don't know what to tell you. I'm sorry. On YouTube side, we'll just be imagining ads. There you go, Terrace. Yes, I like it. Yeah. Well, that doesn't actually sound very good at all. No, let's not do that, actually. You've said it like 4 times. This is so odd. I see your stuff now. I don't know. Line 15 inside of the PID file. Line 15 backslash. Okay. Where is it? I don't have it open anymore. Line 15. Ah. Well, I'd like to think no, but good call. That's weird. It wasn't giving me an error for that. Does backslash mean anything in Python when it's just by itself? Is that the continued line indicator in Python? Is that what that means? Because sometimes, right, you can purposefully in Python do something like self dot IO whatever is going to equal 2 times, and then like go to the 2 times, I don't know, 2. So I think that's the go to next line indicator. I think that's what that is. Yeah, continued line. Okay, thank you. Yeah, there we go. So it didn't actually do anything, but yeah, good call. That was not supposed to be there. That was a typo. Ad blocker going hard. There you go. Yeah. All right, looks like the Twitch side should be back. Quick Google said yes. Awesome. Thank you, Charties. Yeah, confirmed on multiple fronts. So yes, that was a typo, but luckily it was a typo that did nothing. All right, so let's go ahead and test this again. Let's go ahead and make sure. Oops. Gosh dang it! Every time, chat. If I could type, that'd be great. Control Z. Just stop. Okay, there we go. Yeah, you're good now. Okay. All right, chat. Let's do it. Oop. Yeah, I do, Renator. Yeah. I had to think about it. You've got your patches down to 18,000 KSP patches in terms of like the module manager. That's wild, Burgert. That's a crazy amount. I don't know how many I have. I don't think it's over 1,000 though. Wow. What's the why? What is it? Kind of like one mod doing most of the heavy lifting in that, or do you just use a lot of mods? Like, are you using like RSO or something like that, and so that's why so many patches? Ah, Star Systems, got it. Yeah, added like planet packs and stuff. Certainly. That's pretty good. Pretty smooth. I'm happy with that. Oh, that's money, chat. that's kind of money right there. Oh, okay. Let's give her. Let me. I'm gonna give myself just a little bit more room to make sure that the landing gear have time to deploy. But otherwise, pretty happy with that. Actually, that's kind of on point. Yeah, I'm good with that. So we're just gonna make that 0.1. I think that'll be fine. What was that oscillation near the ground? Oh, that's true. It's our horizontal velocity controller, if I'm not mistaken. Where is it? Yeah, horizontal velocity. We're changing our pitch in order to try and eliminate our horizontal velocity. That's probably what it was. I wasn't looking specifically for that though. Because we did change it, but I definitely haven't tuned it yet. At 1 and 0.5, yeah, probably a little aggressive, but. All right, chat, let's take it up. Let's do an envelope expansion test here. Let's see. So we're gonna take it up to, say, 10,000 meters. Keep this Arrow GUI data open because I want to make sure that we track our climb rate as well. Yeah, that was quite the aggressive bonk at the end. We went straight into our vertical descent rate. Yeah, I want to watch that climb rate on that switchover. Because we basically switch controllers. We start off going into basically our hover slam controller, and then there's a point where it then switches, so there's a discontinuity in that switch. So either that was causing the oscillations, or it was a horizontal velocity controller. But regardless, that switch had us go straight from hover slam into -5 constant rate of descent. Straight into the ground. It was a little bit aggressive. But what I would really like to do is hit that gate where we can stop and hover for a second and then enter the constant rate of descent controller. But we'll see. We're going up to 10,000 meters now. Can the API mod allow you to detect other crafts than the currently controlled one and their position? Yes. Yes, Terrace. I'll show you. So if you go here to Space Center, you have active vessel, which is your current vessel, and then you have all vessels, a list of all vessels in the entire game. And then you can set your target to any of those vessels, or you can gather data from any one of those vessels. Yeah. It does in fact allow you to do that. Which is why being able to, say, land a Falcon 9 on a barge in this game is very doable. Oh, you know, I forgot to... Let me go ahead and do that. So this, I don't care about this really much anymore for now. And then DCX simple. Come down here and uncomment out that. And then uncomment out this. For our next run. Yeah. I need to tune the distance controllers here. Oh boy. A little rough, chat. A little bit rough there. Yeah, I definitely need to tune that controller, because that is not it, chat. Definitely not it. So that's our distance and velocity. Yeah, I want to rerun that real quick so I can actually see just how much it's commanding, but that is, yeah, that's not it. All right, that's not it, chat. Nope, not it. There's a way to minimize the hard jumps when swatching control variables with velocity form loops. I just can't remember exactly how we did that. Interesting. I'd have to do some research on that myself. My PC has decided to do what your rocket just did. Oh no. Time to reload those 18,000 patches, huh? All right, so yeah, now we should have the printouts, right? Let me confirm that so we don't just waste a launch. There we go. So yeah, let's see what happens. Going up to 10,000 meters. Because what it seems like is our distance and horizontal velocity controllers to get back to the pad are too low. they don't have high enough gains because we were not commanding a very good, either that or maybe too high of a gain. One of those. It's either too high and so they're basically nulling each other out, like one is too low in comparison to the other one, or they're both too low and so it's not able to command the vehicle to the required pitch to try and get back to the pad. Overly aggressive air-ground interface. Yeah, a little bit. Also, it might be good to give myself a little bit more room going up to higher altitudes. And that's the other thing, Chad, is, you know, we're continuing to change the trajectory and whatnot. So what we find to work at like only a 2,000 meter hop test with different fuel amounts might not work for our large 70 kilometer altitude hop test. So yep, that looked good. All right, so what we got? So yeah, we're commanding pitch up despite us being super far away. So that's not good. Yeah, we're pitch, yeah, it's not good. Interesting. And then I don't know why it does that. Probably because we're too full of fuel, and so it's doing the calculation. It's like, we're too heavy, okay? Because we are coming back with way more fuel than we would otherwise come back with. I'm just going to go ahead and prematurely deploy the landing gear. Boop. No. Yeah. I think it's because we're coming in too heavy. I think that's the problem. As to why it's burning so early and whatnot. But the thing I wanted to test here, chat, is the distance and horizontal. Oh yeah, those are really low. Okay. These were so small previously because we were using the straight error. So we were originally trying to calculate a pitch control using 1700. But now we're using the change in error, which is going to be a lot smaller. So we can definitely increase these. So I'd be curious to see if we just did the same thing as we did previously and null everything out, except for just a proportional controller, and seeing just how wild or on point that is, right? Because we're basically trying to track moving towards the target at 10 meters per second with the horizontal velocity controller, and we're trying to essentially track the pad location with the distance controller, and they're working in series there. Yeah, okay. Actually, no, they're working in parallel. Yeah, they're being summed at the end. Is that series? No, series is where one feeds into the other one. One is not feeding into the other one. Their outputs are being summed for the overall system, so that is not cascading. Anyways, sorry. Tangent. Is there any plan to fully automate routine supply runs? Yeah, 100%. I want to get there, Seacrack, and I don't know how long it'll take. It might take all of next year to get that involved, because that'll be literally the accumulation of everything you could possibly do, right? That'd be obviously fully automated ascent, first stage and second stage, first stage landing for reuse, second stage deploy, second stage Hohmann transfers or any sort of orbital transfers, right? Automated rendezvous, proximity operations, and docking. Yeah, there's a lot of stuff. What's up, New Wing? How are you? So, like, yeah, eventually I want to get that. I don't know how long it'll take to get us there, because I pretty much only work on this while streaming. And it's a lot of test and run and test and rewrite and things like that. So we'll see. I'd love to do that, though. Yeah, I really want to, like, get really into fully automating everything. I think that'd be pretty sick. Alrighty then. But it has to be the same controller, and you just swap the control variable. Oh, I see. I am definitely, I think, running. Actually, am I? Oh, it's because I know what it is, Ubernator. It's because I'm updating the gains. I think that's why. Potentially. Yeah, I wonder if that's the reason why it does that. Ooh, there we go. Now we're getting aggressive. Look at that. Now we're pitching, commanding almost negative 40 degrees. I like it. It's getting into its proper orientation. Ah, okay, okay. A little bit too much, though. Yeah, a little bit too aggressive here. Yeah, that gain's a little high, a little high. That's why it's oscillating so much. And it's actually tracking the 10, which is kind of interesting. So I wonder if that means that we can improve it. Be aggressive. Be aggressive. What is that from? Stop! All right. So we were moving 20. It was commanding positive 20. So this is our distance to the pad, this is our horizontal velocity towards the pad, and this is our commanded pitch angle. So it's commanding 20. Interesting. You know, I'm honestly wondering, chat, if this new controller design doesn't require the 2. I want to null out that velocity controller out of curiosity here. I want to see what happens. I want to see if just the distance controller is good enough now, because before it wasn't. Before, the distance controller was not good enough. But I am curious to see if, now that we've updated the control architecture, like the controller design, if it's actually going to be a little bit smoother than it was before, which means that we can get rid of the horizontal velocity controller there. I don't know, just a thought. I just want to see what happens with the distance controller only working. Because the distance controller, right, because we are a kilometer away from the pad, should be commanding a pretty heavy pitch down in order to try to pick up velocity to start moving towards the pad. But we'll have to see. I think we will probably still need the horizontal velocity controller as a regulator, because essentially we don't want to go too fast towards the pad, right? Like, so we basically use the horizontal velocity controller as a regulator, saying like, yes, we're really far away from the pad, but we're also moving towards the pad at 100 meters per second. So we don't actually have to continue pitching down in order to try and increase our velocity. So I'm wondering, so we'll probably still need the horizontal velocity controller, but we'll see. We shall see. So yeah, let's run it. I just want to make sure that the distance controller is still looking good. Probably tune it a little bit as well if it's oscillating a lot. I think it would be cool to do a pre-programmed probes in the early game with this and trust your code and KSP engineering to get the probe to do what you want to do. That would be pretty crazy, yeah. Yeah, we haven't done any interplanetary missions yet. Doing interplanetary transfer, though, calculations would be... I don't know how to do that off the top of my head right now. Just thinking forward. Probably every kid's baseball or softball. Yeah, but the kids get it from somewhere, right? Yeah, exactly, Ubernator. Ah, interesting. Nice. That's a good call then. Where do you want to go first for your interplanetary things? Duna. Duna's in 295 days for the transfer window in our career mode. And I think we have a contract for it as well, so. All right, there we go. So it should be commanding as much negative pitch as it can, and it is, because we're very far away. Okay. You know, I almost wonder if a cascading controller would actually be better here instead of just having them summed at the end. Oh, what the heck? Interesting. Not sure. That's interesting. Is that just the gains that's oscillating so much like that? That was doing some weird stuff. We're still 1,200 meters away, and it's pitching up, and it should only pitch up to try and slow down. What is its set point? 0? Why? Interesting. Because it's still a kilometer away and it was trying to pitch up. Yeah, it was pitching up almost the entire time here. And there it's going negative, pitching down to try and increase our velocity, to try and move towards the pad. Yeah, that's interesting, chat. Let's bring this down some. Let's give it a small amount of integral. And I might even need to implement some derivative term as well if it keeps oscillating. Because it should, basically, because we're so far away, should be commanding maximum angle. Until it gets closer, or until it starts reducing that error. The distance controller was added to the well, it's not the velocity, right? The pitch input. Yeah, we're getting the linear distance to the pad in the XY plane, the Haversine distance, and that creates a pitch, and then that's going directly into our pitch input. Well, I'm sorry, this is the wrong controller, but Yeah, the same thing basically. We have our pitch input, which is our distance. Yeah, same thing. It was oscillating a lot though, so I don't know if that's just... Well, the command it was, so it had nothing to do with the autopilot or anything like that either. Okay. Alrighty. I think the jewel transfer is at 180 days into the game. Could check that as well. Oh, we're way past 180, right? We're somewhere on the order of like 600 now, I think. You need the max relay antenna to get out there. Gotcha. Gotcha. Actually, you know what? I actually wanted that. I keep forgetting to watch my climb rate when we get close to the ground, because I want to make sure that this is actually going to try and manage 5 meters per second well. All right, so once again, we coast up to 10,000 meters. I had to redesign my small scale launcher when I found out so they fit in it. Nice. Yeah, gotcha. Oh, the relay antenna. Yeah. All right, we're coasting. And there's 10,000. We overshot because I was fast forwarding, but that's fine. I was physics warping. All right, there we go. Tracking the pad. Okay, there we go. Oh, I know why. It's going to change right here, isn't it? Right now. Yeah, there it goes. It starts to change quickly because our velocity, our error is changing so much. Yep. Got it. Because our change in error is so fast. Got it. Okay. Fair enough. Okay, trying to burn back towards the pad at this point. Did you get the pad coordinates? Believe it or not, I took a truck out there, stopped it, and then printed the coordinates out. Well, I didn't print the coordinates out, but in the game, if you look at the in the game, if you go to, I think it is cheats, set orbits. Is it set orbit, set position? These are the coordinates that you are currently located, and so I copy and pasted them from here. I drove a truck out to the pad and then took them from there. Yeah. How much longer am I alive? Another couple hours. Yeah, probably like another hour, hour and a half. Hour and a half to 2 hours. Yeah, my pleasure, Rach. So yeah, because we're basing it off of our change in error, it's still going too fast though. It's still going too fast. Like way too fast, actually. So I'm curious. Bump that down another order of magnitude. Could also give it a little bit of a derivative term as well. Ah, I got your rage. There you go. All right, let's go ahead and track it. Yeah, but I'm wondering if we actually should do a cascading controller here. Because we can essentially use... Do we use our distance to set our... to be a set point for our horizontal velocity? And then we try to manage the horizontal velocity? Or do we try to use a horizontal... No, I think it should be distance into horizontal velocity, right? Yeah, we want our horizontal velocity to be based on our distance. If we're very, very far away, we want to try and pitch down so we can get a lot of speed, so we can move back towards the pad faster. So I think it should be a distance controller setting, cascading into our velocity controller. It's one way to test things anyways. It just might be a little bit better. I wonder how that would do with mitigating overshoot as well. That's actually looking really good right now. Oh. Okay. That was weird. Why is it doing that? That's a new one. I don't know why it's doing that. The command, it's not changing that drastically, but for whatever reason, it's continuing to go vertical and not. Yeah, I got nothing on that one, chat. That's a new behavior. Are you gonna straighten out here? There you go. That's a new one is not what you want to hear. No, it's really not. Because it was doing some fancy things there, chat. Some fancy things I did not like. Wait, let me tell you what, chat. Yeah, I don't know what that one was all about, to be honest. Yeah, I want to try that again and see if it does the same thing. I'm sure it will, but I want to see, is it actually outputting a commanded... Oh, you know what I could do, chat? I could actually set a rate limit as well. Maybe I should do that. Oh, I should totally do that. Yeah, I have a rate limit I can set. That actually might be good to do. Hey, what's up, Backfire? How are you? First time I've seen anyone do something like this. Well, I'm glad you're enjoying it. Glad you're enjoying it. Yeah, we've been at this for quite some time. Definitely. Yeah, we built this entire, like everything that we're working in Python right now, built it from scratch. It's taken many a months to get to this point, but we're trudging along. Trudging sounds bad. We're marching right along, yeah. We're not really trudging. Trudging indicates that we're struggling horribly. I wouldn't go that far. All right. Hit that altitude hold. Altitude hold looks good. Continuing to look good, yeah. 0.8 meters per second and falling. Maintaining altitude. Yeah, good. Okay. Pitch back to the pad. And let's see what happens here. So right now it's at -20 commanded pitch. Oh. Well, okay, that's fine. I'm still printing out what it should be with the horizontal velocity controller. Oh no, I'm sorry. I'm looking at the wrong number, chat. Sorry, that's our velocity. This is our commanded pitch. See, I don't see it change to be negative, but it did whatever that was. It's doing whatever it's doing here. Oh, that's really strange, actually. And now it's gone too far and it can't write itself back. What am I printing out here? It says -20. Distance to pad. Distance pitch. Yeah, I'm printing out the distance pitch, right? On both? Distance to pad. And that's our pitch input. Oh. Yeah, we're going a little fast, chat. We went a little fast there. La, 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 la. All right, so we're printing out 2B here. To be or not to be? And then we switched to 2A, right? Yeah, we switched to 2A, okay. But we were -20 like the entire time almost. So is that... And what am I printing in 2B? I'm printing the pitch input. Oh, that's so strange. If I'm printing the pitch input, then why is it doing what it's doing? I'm printing the pitch input. Pitch input is here. That's being... I do have a low pass filter on it, which is interesting. That's right, I do have a low pass filter on it. That might not be enough though, with its current design. Let me, yeah, I don't know why it's changing so fast. Those are some pretty huge oscillations. Let's see here. So 20, -20 deadband rate limit. Okay. Let's do rate limit at 0.5 for now. I want to see if that helps, and then we'll run it back. Yeah. But I don't know why it would be doing all those oscillations, but the printout looks fine. So either it's commanding that massive change in pitch faster than what the print statement can do, faster than what the terminal can print. That's kind of weird. Yeah, the print, or not the print, well, yeah, the print of the pitch input should be fine, because it's actually what should be going into the autopilot, the target pitch. So whatever this is printing should be correct. Like -20 should not have been doing this. But yeah, we can definitely, instead of doing that, let's change this to distance pitch. I'm curious. It had great comedic timing indeed, right? Always. Launching and occasionally crashing. Yeah, exactly. Hope you have an airbag. Never! My tentative food supply for the first crew mission is at 30 tons. I think that'll be a proper challenge. No kidding. Yeah, I'll have to look at your rules that you posted again on Discord, because I definitely do, once we get back into like mission stuff, start incorporating something like that with chat's permission, of course. Chat's vote. Okay, should be about to start coasting here. There it goes. There we go. Yeah, exactly, Ubernator. Of course, we're not printing the distance pitch variable. We are now. So it's here. That's our velocity. It's this. So we should be pitching -20 degrees, and it looks like we are -20 degrees. So that looks fine. Yeah, so it's not the pitch controller then, right? Something else. Something else is happening. Yeah, so something else is happening. Is another if statement getting triggered somewhere? But we're not changing modes. That's what's so weird. We changed modes there, which is fine, but we were still at 2B, which should be here. And should not be, yeah, there's mode 2. We should only enter mode 2A. Because see, mode 2A makes us go 90. But we don't enter mode 2A when it starts doing those flips. And nothing looks weird in the commanded pitch. It looks totally okay. I don't see any jumps to positive numbers. I have a rate limit on it anyway, so it shouldn't just be able to jump positive like that. I also have it clamped. It should be clamped to -20 and +20, so there's no reason why it should kick up all the way to like +70 or something like that. We have no velocity getting put into our pitch. Target roll is doing nothing in that one, but target roll, yeah, I don't care about target roll right now. Let's keep target roll out of it. Actually, I'm sorry, not that. Yeah, this. That shouldn't be doing anything. That's not changing a pitch. So yeah, I don't know what's being triggered in order to change the pitch like that. Was that manual or auto? A little bit of both. I was just giving it some taps to try and kick it over, but otherwise it was doing everything itself. Oh my god. What? Wait, no. Because we're not at 1500. Or is that when it started happening? Is that when it started happening? But it should only do that once, though. Okay, stand by, chat. Maybe this is what it is. Yeah, we don't need the low pass filter on that anymore. We have a rate limit. I'm just going to do pitch input here for now and see if that fixes that. Because if telemetry horizontal velocity is greater than 50 meters per second and distance to pad is less than 1500, then that. But why was it oscillating though? It was like it was trying to switch in between these two, despite the horizontal velocity never going. Well, no. All right, let's do that real quick and see. Yeah, let's do that and see. Can you write a different output from the vessel class? Like line 295 is what I wanted you to print. Oh, line 295 is what you wanted to print. Gotcha. Yeah. Yeah, we'll see. And what did you want to print? We're getting there. We're honing it in. Just certain things are needing to be updated. Yeah, I'd like to know if it was that line, because if it works perfectly now, well, then we'll know it was that line. If not, then I'll put it back, put print statement there. See if something else is happening. Yeah. Yeah. Anyways, time to time warp a little bit. Could have shutdown, time warp again. And there we go. Then enter altitude hold. There we go. And tip it over. So it is commanding negative, maximum negative now. It's looking stable. We're picking up horizontal velocity. There we go. That's looking better. It's going to overshoot now, though, by like a lot because we don't have the horizontal velocity regulator. Yep, it's trying to turn around and pitch down so it goes that way now, but it picked up way too much velocity. It overshot. That's funny. It's like, no! No! Yeah, that's why we implemented that horizontal velocity controller. Cascade fixes that. Yeah. I was I don't know if you were in here, Ubernator. I was questioning, is it better to have your distance controller cascade into your velocity controller, so that way you could essentially set your velocity based on the distance, right? Isn't that the way to do it? I think that's the way to do it. Climb rate is 5, by the way, so that is good. Yep, going way too fast. I'm gonna say yes because you love cascading. Yeah, that's fair. Yeah, I wouldn't mind trying that instead of having this summation that we have here. Yeah, I'm good with trying that out. So we have distance to pad, having that set. Okay. That means that we're gonna have to change our controller. But anyways, because what did it end up doing at the end of 2B there? How long did it take to? The climb rate was right. Yeah, exactly. So at 200, it was commanding pitch up. So that'd be essentially trying to achieve 0 if we max it out there, right? Yeah, it'd be trying to achieve 0. So we'd have to flip it at 0. Trying to think here on the design here. So yeah, if we implemented a cascading controller, then we would have a distance controller go all the way up to, say, I don't know, negative 100. I'm sorry, positive 100. Yeah, positive 100. So it should be 0, positive 100. See how this works for a second. So that's our distance controller. So our maximum velocity that we would want to have is 100 meters per second. Our minimum is 0. Yeah. Okay. And so distance pitch, we'll keep that there, but we actually want our hvel controller dot set point set point equal to distance pitch, and we check our current horizontal velocity, and velocity pitch is going to be equivalent to that. Yes, which is, we have our set point. Yeah. Okay, let's try that out. I'm curious. And that's there. Okay. And then we gotta do the same thing down here, yeah. Yep, we gotta do the same thing down there. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and we implemented the 1. Good. All right, that should be good. So yeah, now I want to do distance pitch. I don't really care about the heading. We know the heading works. Roll and roll input can stay. This now needs to be velocity pitch, which is also our pitch input, by the way. Yeah. And current horizontal velocity. Okay, well, let's see what that does, chat. That might not work at all, but we'll see. But this is what's known as a cascading controller. You have basically one output from a control loop be the input of a second controller. So right now we're essentially trying to set up our pitch based on our velocity towards the pad or away from the pad, but that is also defined by the distance from the pad. So we'll see how this goes. Yeah. All right, Shed Ghost, there we go. And we'll time warp. Once you get to a certain distance from the pad, flip to start slowing horizontal. Yeah, that's what we had previously, which is what was kind of, it wasn't tuned anymore, so it was causing it to kind of freak out. So that's what we did originally, Rage. Yeah, we can certainly re-implement that. That's fairly simple to do. All right, so now 0. Wait. Oh, yeah. Okay, I'm sorry. That's our horizontal velocity. It's trying to get to 0. Oh, does it need to be positive? Oh, it needs to be positive and not negative. Am I silly like that? Or... wait, where did I put that? Yeah, it's trying to command 0. Which is not at all what I wanted to do. It's trying to command 0. Got it. Horizontal velocity controller, where are you, bud? I don't know if the horizontal velocity is going the right direction now that I saw that. But anyways, Let me see here. So that should be right, but I need to flip it because it's trying to command 0. Is that what I saw like through the whole time? Yeah, it's commanding 0 the whole time, when in reality it should be commanding positive. Let me try switching that around real quick. But not, yeah, okay. Curious. Why is it giving it a negative? Our set point should be the pad, or our set point should be 0. But then based on our current... No, that's right. Okay. I was just, yeah. No, that's right. It should be negative. All right. Yeah. Yeah, cool. Yeah, I think that works. All right, coast up. That altitude controller works wonders, chat, gotta say. All right. So velocity is saying 10. Oh, it's because, oh, I'm so silly, chat. I have the negative sign here, so I'm switching it. Oh, well. No, there it goes to a negative 100. Wait, what was it before? Very, very small. Okay. Now it's commanding negative 20. We're going really fast now. Wait. Why did it take so long to get to that point, though? Okay, stand by, chat. You gotta... I think I'm misaligned with what I was printing out. Let me see. What was I printing out here? So distance to pad. So going here, we have distance to pad, current horizontal velocity, and then our distance pitch. Yeah, okay. And then next to that, our velocity pitch. Ah, okay. So velocity pitch. Which is our actual pitch, is 0, or very close to 0, despite the negative 100 that's trying to be implemented here. And then I don't care about the other two right now. Okay. All right, so we have our distance to pad, which is basically telling us how far away we are from the pad in the XY plane. So linear distance to the pad. We have the pitch, distance pitch, or the commanded output from that controller, because we want 0 error, and right now our distance to pad is that error. So that should work, and that should be a distance to pitch, which is currently negative 100, say. So as soon as we get into that, right, we should very quickly go negative, right? Yeah, pretty quickly we get negative. I almost wonder if it needs to be even faster than that. But anyways, okay, so we go very, very negative. And then our horizontal velocity controller, it's set to that. Yep. And so it's pitching up. Yeah, I don't think that's correct. I think I need that negative, and I wonder if I need a little bit higher gain on distance now just to make that response a little bit faster. Okay, try it again. This is tuning, chat. Aw, man, why you gotta be like that, game? Oh. There we go. Looking good. Just missed it. Missed it by that much. All right, let's go ahead and get up there. There we go. Taking off with a burnout and smell of cooked rubber. Yeah, no kidding. Yeah, a little close, I'd say. Just a teeny bit close. All right. So yeah, we are commanding big time pitch. Big boy pitch, chat. Big boy pitch. All right, pitching up. That's actually pretty good. I don't know if it'll be fast enough though. We're going pretty fast here. Set to 0, but it's not pitching up anymore. What are you doing? Oh, it's because it overshot. It doesn't know what to do, chat. It doesn't know what to do anymore, chat. It doesn't know what to do. It's freaking out, man. It's given up. It's given up on life, chat. That's all I got to say. It's given up on life, yeah. Oh, righty then. So maybe it actually needs to be able to go positive, which is interesting. Either that or, like somebody said before, changing it to just set a constant pitch up if we get too close too fast. So that was fine. That can be fine as well. We can actually even implement that a little bit better as well. But let's go up to 100 just to see what that does. Testing, because I'm not sure how that's actually playing into the cascading controller. F5's in chat, yeah. Yeah, that was a super exciting test, chat. Let me tell you what. You watched Get Smart as a kid? Nice, yeah. Yeah, it's pretty good. Yeah, you need to be able to go positive and negative. I was thinking that because... Yeah, you're right. I was thinking that because our distance controller was basically setting our desired horizontal velocity, that if it was set to 0, then it would pitch up anyways. But you're right, it probably needs to be able to go higher to warrant a better response. But we'll see, yeah. You wouldn't clamp it at all? I don't know, man. If it's maxing out at positive or negative 60, whew, I feel like we got problems anyways if we unclamp. But maybe. Yeah, exactly, Rage. That's true. That's a good point. There we go. Yeah, maybe. Maybe. Because what is our horizontal velocity set to? Oh, it's only proportional gain. Well, I mean, that should be fine though for this. I do have that set point different though, right? I do change that set point down here. Yeah, HVL set point. Okay, cool. All right, we're getting fast. It's still not pitching up. All right, we're starting to pitch up, but not really still. And then it's like freaking out because it goes past it. Yeah, it's not behaving as I'm intending it to behave. And slam into the ground. Do you think it's a steady state error? Because it does flip eventually. Or we can certainly add an integral term. It's probably the next thing to test anyways. Yeah, it doesn't, so where did it hang up? Let's see, that's the start. We were maxing out. So that's distance. That's horizontal velocity. We're moving away from the pad. That is our distance pitch output, which is our horizontal velocity set point. And then that's our horizontal velocity pitch. It's commanding negative. We're starting to move towards the pad. It's starting to come up, and it is therefore also starting to come up. But we're still too negative. Yeah, still way too negative. And we're going way too fast. And then it basically stops at negative 40. Yeah, interesting. No, it doesn't stop at negative 40. Interesting. Interesting. Let's see here. And horizontal velocity, we have 1, now we have that. Negative 60, 60. Dead band, so small it shouldn't matter. Okay. Now that's 2A, 2B, or not 2B. As our pitch input set to that. Yeah, okay. We did fix that line, so that's good to know. Horizontal speed. We're getting our velocity. I'm wondering, I feel like that's a fine. I'm also wondering if it's how I'm calculating this, because technically speaking, having the set point be negative 100, this should be the same. Like, it should be fine. Anyways. Well, let's run it back, chat. Add the integral term. It's deadly. Yep, we shall see. We shall certainly see. All right. $295. 295 is not the same 295 anymore. I changed it. I don't take the negative anymore. Yeah. There we go. Coast on up here to 10 kilometers. We're getting there, chat. like I said, this is at least good because we know that the control system works just fine. It's just now making sure that the change in the controller design doesn't mess anything else up. So it's just a matter of tuning, make things a little bit better. Quite frankly, what we're doing right now doesn't even really need to happen, you know? But hey, what's up, Sleazy? How are you doing? Good evening, first time viewer here. You just happened to show up in my recommendations. Love me some KSP, lots of hours, but definitely not an expert. Hey, what's up, FS? How are you doing? Yeah, I'm glad you're hope you enjoy the stream, my friend. Sorry to be late to the party. Would you be willing to give a high-level overview of what you've been up to? Yeah, so we have developed a lot of code in Python using a mod called KRPC to communicate with the game. And so right now we are testing the control systems that I have rewritten since last stream, and making sure nothing is hopefully too changed too much. All right, so we're moving really fast here, chat. I gotta change that. I gotta change that for sure. But it's not changing it from -60 now at all. Oh, now it's changing it to +60. Wow, that was super, super fast. Wow. Yeah, that did not do what I wanted to do. Are we getting a big rocket launch tonight? Probably not tonight. Not how this is going, unfortunately. So either that is way too much integral or that's not the problem. Yeah. I think for now, just because it's not something I was looking to change tonight, let's put it back the way it was. Yeah, let's put it back the way that it was. And I want to make sure that before we start changing things, changing the architecture and whatnot, I want to make sure that the PID controller that we've changed doesn't mess anything else up. Before we go down that rabbit hole, like set up a program to achieve a goal, hit start, and then go hands-free or something else. Yeah, basically that. The, I guess, close immediate goal is to do Falcon 9 automated landings back at like a pad. So we are using, well, nope, we're not using that. We're using the small vehicle that we've been testing with just as a simple test. If you know SpaceX's Falcon 9, or I'm sorry, not Falcon 9, their Grasshopper from years ago, they started with a very subscale demonstrator to test some of their avionics and control systems before putting it into Falcon 9 for soft water landings. I'm kind of taking the same approach. We're starting off with this suborbital test vehicle to basically test all of our control systems and whatnot. This little guy. All right, so let us see where we left off before going down that little bit of a rabbit hole there. So that should all be fine now. I don't know if that negative is necessary anymore. It was originally. Oh yeah, that's right. We did test this and it was working. So let's actually null out or get rid of the null on the velocity regulator. There we go. Let's see what happens now. Starlink launch in 30 seconds? Really? Well, interesting. I did not realize. I didn't know that was happening tonight. Is it actually happening? Is it seriously in 30 seconds? That's a bummer. Really have not been keeping track. Oh, hey, 5 seconds, chat. Nice. Good timing. Yeah, just, you know, a casual rocket launch as we're trying to do our own rocket launch. Speaking of SpaceX, right? Speaking of Falcon 9.
Dude, when propulsion is nominal.
Oh no, FS, distract away. Ask all the things. Yeah, it works. It works perfectly. What the heck? Just tap it. But yeah, another Starlink mission. They're over 8,000, right? Haven't they completed their original 8,000 some odd satellites for their first shell? In the future, you plan to catch the booster. Yeah, in the very far future, I plan to catch the booster, 100%.
Vehicle is supersonic.
Supersonic. So we're already past, or we're approaching max Q. Where's this launching out of? I didn't see, I think this was Kennedy, right?
Max Q.
How many does Falcon 9 use? I don't know if Falcon 9, well, they probably do in some way, shape, or form. I was gonna say, I don't know if Falcon 9 uses PIDs, but they probably do, yeah. Everything gets boiled down to a PID loop. But yeah, I have no idea. Is there any mod for that? It wouldn't surprise me if it would actually surprise me if a mod did not exist for that. Excellent work, pro streaming as usual. Yeah, you know it. Yeah, exactly. Whatever. Yeah, like I said, I know that they were.
And back chill is underway.
Nice. So they're pushing through on the second stage engine some locks in order to make sure that there is no big changes in pressure and temperature as they actually ignite the engine. So they're trickling some liquid propellant, liquid oxygen in the second stage engine. Man, that looks fantastic. That big balloon effect as the under expanded gases come out of the first stage engine nozzles, which are optimized for sea level. Well, at least I should say lower atmosphere. But yeah, I know SpaceX was very near completing like this launch or last or something like that of their original 8,000 satellites for Starlink. I think they have licensing to be able to go all the way up. Second stage SEP looks good. All the way up to like 20,000 satellites, but that's over many years for refreshes and things like that. But yeah, they're almost done with Starlink in terms of it is Slick 40. Okay, cool. Yeah, nice. Yeah, you can see the Space Coast. That looks like it might be Daytona right there on the coastline. Off over in the distance here, Orlando. Bearing shell deploy. Does it have gas molecules in the Falcon 9 tanks after burning the liquid? Oh yeah, 100%. I mean, there's all sorts of dissociative particles in there. Everything from the pressure that they were using, like helium, any sort of oxygen that's been boiled off from its liquid oxygen, RP1 fumes. Yeah, there's definitely gas molecules in there. Pretty colors, pretty lights, yeah. Aren't most first stage engines optimized to be as high altitude as possible before the outside pressure becomes too great and the engine fails? Yeah, I mean, yes and no. There's always a trade-off, right? Because if you want a engine optimized for a high altitude for low pressure, then you have to make your nozzle larger. So it's a trade-off between how much, what am I trying to say? Your thrust to weight ratio for each rocket engine, right? Because it at some point becomes impractical to build a larger nozzle, especially for the thrusts and things that you're trying to put. So yeah, you try to. There's a lot of different variables in it though. You haven't been watching a bit of this? What happens? I think, was it you, Ubernator? Brought to my attention that there was a Falcon 9 launch happening, and we tuned into it 5 seconds after engine ignition. This is Starlink. Like I said, I want to say this flight, or one of the flights very soon, finishes the original 8,000 satellites that SpaceX wanted to put up for Starlink. They have, plans to continue, but I'm just saying that was the original plan, was 8,000 in their original license. And I'm pretty sure they're now over that, which is pretty cool. The infinity nozzle has not been invented, true. How does the engine light back when coming to landing burn? So inside of the Falcon 9 engines, they have pyrophoric, meaning that as soon as it touches oxygen, it wants to ignite. Pyrophoric chemicals in like cartridges. And they basically open valves to these cartridges and let that pyrophoric fluid flow into the combustion chamber as they flow liquid oxygen. And so the liquid oxygen, being oxygen mixing with pyrophoric chemicals, makes a big combustion, and then they start flowing RP1, and then you get stable combustion. That's how they do it. Yeah, it's called TTEB, triethyl aluminum triethyl borane. TTEB. Here we go. We have supersonic retropropulsion as a vehicle tries to not only slow down in order to come in for a landing, but also trying to protect itself from the very hot stuff that we saw Starship handle beautifully in flight test 5 and 6.
Stage 1 entry burn shutdown.
How does that slow down the speed? How does what slow down the speed? Burning retrograde. So it's basically burning its engines under thrust, and that's helping to decelerate. Supersonic exo-atmospheric retropropulsive burns. Yeah, that's another way to say it. Can't wait for the Pez dispenser. Me too, Panta. Ooh, oh no, come back. X live stream, you're failing. You're failing right now. I was gonna say, but look at this. You can see some of the plasma start to accumulate. What the heck? Is it just me? Or did the stream go down? I'm still streaming. I'm not dropping frames, so I don't know what's going on. I think it's Twitch. I think I think it's Twitter. I think it's X. Well, what a bummer, chat. All of that, we don't even get to see a landing. Really? No? Maybe? Refresh the page? Okay. It's working for me? Okay. Well, let's roll it back here. I think I fixed it now. We just had to rewind a little bit. Oh, that plasma's looking good, chat. Yeah, we're a little bit behind now because for whatever reason, X stopped working for me. Yeah, that's true, Mad Chad. It's true. Oh. Drone ship.
Stage 1 transonic.
That one light in the sea of blackness. Drone ship. Looking good. Second stage nominal.
Stage 1 landing burn.
Stage 2 terminal guidance.
How does it see the boat? Well, it doesn't use vision systems, as far as I'm aware. It uses like GPS coordinates and probably radio frequency timing, LiDAR, things like that, which don't actually have to see. But yeah, it's mostly GPS. And I'm also wondering if Starlink has any sort of alternative position navigation and timing capabilities. God, they make that look so easy, chat. They make that look so easy. Oh, man. Well, there you go. Thanks for watching. Yeah, it's a Starlink mission, so they're pretty much going to cut the feed here as soon as Seco happens. So yeah, there you go, chat. Beautiful Starlink launch out of nowhere. Yep, INS for sure. Same way Super Heavy sees a tower, it's radar guidance. Is it radar? Is it actually radar? I didn't think it would be radar. Well, no, I guess, yeah, I can see that. I was definitely not thinking radar, though. Is this still being controlled here? Oh, it is still being controlled here. Huh. Well, how about that, chat? Here we go. Go. Yeah, that's pretty cool. I didn't really consider radar, but makes sense. There we go. My kids just walked in and asked what I was watching. Live stream of a guy watching a live stream. Yeah, that's about accurate. Yeah. Yeah, 100%. Is that little evaporation dribbling on the drone ship following landing locks? Possibly. I'd have to look at it again, but probably. Probably a little bit of unburnt locks or superheated RP1 or something like that. It's a loop, yeah. They cooked the antenna because an abort to ocean caused it. Oh, that's what caused the abort to ocean. Gotcha. Nice. Yeah, we saw the antenna having a bad day for sure. Why doesn't the rocket land on the landing pad in the middle? I don't know, honestly. I don't know if that's, you know, on purpose, if they offset it, or if that's, you know, a slight deviation in the control system, right? I'm not sure. It's a good question. And I don't know. Couldn't find the tower, so they aborted offshore. Yep, gotcha. All right, now what are you doing? What am I printing out here again? So current horizontal velocity, distance, pitch, roll. Okay. Wait, okay. I'm trying to remember what we had working for us. So pitch input. So we have distance pitch. And are we printing out distance pitch? We are printing out distance pitch. Currently 0. Ah, we cut. Wait, no. Why is distance pitch 0? Because it is pretty much set to 0 here. Zero, 0, 5. All right. It's not bad. That certainly seems to be working a little bit better than what we had not a second ago. Cascading control is going to take a little bit of finagling, I think, to get it to work. Yeah, that works. Is that legal in Florida? Is what legal in Florida? Is this legal in Florida? No, absolutely not. Would ChatGPT do all of this? I have no idea. I would hesitate to say yes. I don't know. I don't trust ChatGPT for coding. I mean, it'll get you in the ballpark, right? But I don't know how much it knows of all of this stuff. I have no idea. Like, it wouldn't surprise me if it could, but also at the same time, I still wouldn't. I don't think trust it. It's crazy that that's become routine. Teaching a rocket to land itself on a boat. We live in a future. Yeah, I know, right? It is pretty wild. All right, so what were we seeing in mode 2B? That's what I want to see here. All right, so we have distance, velocity. We have our pitch, though, which is kind of odd. And our distance controller should be up. I see. Because of this right here. Yeah. Negative 20. 20 is what we originally had. There we go. That probably explains why that happened. And then the other thing I want to see is the horizontal velocity pitch as well. Yeah. So velocity pitch is what it's called. All right. I don't need that. All right. And I don't need that either. Okay. Perfect. Yep, let's run it back. Do you watch Mike Abbott? I do not. I'm not familiar with Mike. The fish have yet to file a complaint. That is true. They have yet to file a complaint. They're probably happy with some of the new wreaths. Would you have your second stage with an automated landing system in the future? Yeah, 100%. Yeah, I want to get to fully reusable systems. Like I said, baby steps, right? Yeah, it's pretty crazy, Uber. The every 4 days sort of thing. Yeah, I think I was gonna say that as well. As I think it's definitely intentional that they don't land it directly on the center, but I haven't done the comparison to see what their dispersion and landing actually looks like. We know from DOS, right? DOS, I think said they have like a 90% accuracy to get it within the circle on the barge landing system, which I don't remember. You could probably measure it by going to Google Maps and doing, or Google Earth, and finding the actual barge anchored at the Cape and measure it and see what that dispersion actually ends up being. But clearly it's good enough to carry over into super heavy to do a tower catch. That's pretty insane. Yeah, I'm just gonna put that out there. Pretty insane. All right, let's go ahead and see. Yep. So we are moving towards, we're at -20 on the distance. Oh, interesting. Yeah, no, that's good. And so we're trying to track that 36 meters per second towards the pad. Yeah, so we definitely need, oh, I wonder if that would be good. Can we just set up like a simple, gosh, you definitely could do that, couldn't you? I'm trying to figure out how I want to do this. It would be relative to the ratio, yeah. Oh, look at that, chat. Oh. Tease it. Oh, no. Huh. Well, we got pretty close that time. We could actually set up, a simple ratio. To set up, okay, so I'm thinking there's a really easy way to change how much we're commanding based on our velocity, right? Yeah, there's an actually really easy way. Because right now we have basically a set horizontal velocity, desired horizontal velocity. And so it's basically, I think, trying to match like 30 meters per second or something, moving towards the pad. Where in reality, if we're really, really far away, we want to change that. So we could say, hey, we want to set our horizontal velocity to try and match 100 meters per second, and then update that based on the ratio, or like maybe an exponential value, maybe an exponential value. So it'd be like 100 plus the exponent. There's something there, right, chat? There is something there. Or distance from the pad. It could be sort of like that. It'd have to be a ratio or something like that. Say like, okay, it's going to be 100 meters per second times, say, our distance to the pad, relative to, say, 1,000 meters or something like that. Or 100. Our distance to the pad over 100. Right? Yeah, once we get closer to the pad, we lower, yeah. It could just be a simple division. Yeah, I'm trying to think about how I want to do this. One second. Let me see. Do I already have something like this implemented? Back when we were testing like proportional navigation. Yes, I did. I did do that. It was right at that line, chat. Yeah, for the compensation we did 100 times 1 minus the exponent of our altitude divided by 300. Let me go ahead and take that as a potential starting point here. Yeah, so we have our current horizontal velocity, and then we want to do hvel controller.setPoint is going to equal that. So maximum of 100. We don't have altitude, but we do have distance. Distance to pad divided by 300. So let's just test that for a second. So if we get our handy dandy notebook out, right, our calculator, if we said we were at 100 times 1 minus the exponent, yeah, that should be fine. Anyways, 1 minus e raised to the negative, say, 1,000, right? 1,000 meters divided by 300. So what does that get us right now? Then that would be 96, okay? And then as we got closer, say we were at, yeah, my brain is moving super slow. I don't know if you guys can tell. It's been a long day. I got that like sickly brain fog. It's really showing. Yeah. And if that was supposed to be 300, then we would be at 63. So if we were to move that to say 1,000, I'm trying to figure out how much time would we want to slow down, right? Because we could do say 1,000. And we want to change that. That'd be 25 meters per second. That would still be, I think, too much potentially. But you see where I'm going with that, right? I think that might be the way to do it. We just gotta figure out what the right ratio is. Because if we're at 300, that would be 26 meters per second at 300 meters away. Could be it. I'll keep an eye out for more stuff. Thanks for the chat. Yeah, have a good night, my friend. I hope you enjoyed the stream and all that. Yep, we will be back tomorrow, same time, 7 p.m. Mountain Time. That's the goal. All right, let's try that. I'm curious to see if that's actually going to work. Yeah. That should be a maximum of that. So what does that actually end up being if we're like, say, 10 meters from the pad? Or even like, say, 30. And that's 2. Yeah, okay. Maybe. That might be something here, chat. That might be something here. Let's hit the go button. Just do it 3/4 period instead of 1/4 so you don't smack Jewel. Yeah, exactly. Yeah, you gotta find the right ratio so that way you don't you don't go too far in or too far out on your transfer orbit. All right, let's go ahead and time warp. Go right about there, put down, continue time warping. There we go. There we go. Awesome. Let's see what we got. -20 and -56. Yeah. So we're pitching down so we can start moving towards the pad. Here we go, starting to move towards the pad, starting to pitch up now. Not bad. So that was a little bit too much, maybe? You know what? I should look at the set point and see what the set point is. Skirt, skirt. Still gotta work on the horizontal velocity as well. Son of a gun. This is just manually doing the math? Yeah, I guess so. I guess that's essentially right, yeah. So that worked. Like I said, now it's just a matter of figuring out what would be the right thing. I should definitely print out the set point so we actually know and see how fast the controller is actually trying to match it. So yeah, let's do it right here then. So this is going to be hvel controller.setPoint. So I want to see if it's actually able to match it here, right? So if these numbers are essentially equivalent, we'll know it's doing pretty good, or at least trying to, right? If it's pitching up to try and slow down and things like that, that should help verify. You know what? Before I do that, I don't care about doing a 10-second hover anymore because we know that that works. So we'll do a 1-second hover. Just have testing go a little bit faster. I guess I can time warp all the way up. There we go. And then kick over. Yeah, so we're pitching down. Okay. So our target horizontal velocity is 75. So it's pitching way down to try and match that. There we go. So it's trying 73 now. Pitching up. Yeah, it's actually doing pretty good. And now it's continuing to pitch up because it's trying to match 50. Oh, it actually might need to go a little bit faster or have a bigger integral term because it actually, yeah, has that error there. It's not able to keep that going. Because that's our set point, and our horizontal velocity is not matching it. Like I said, it's not doing bad. Just could do better. Oh yeah, we did. I forgot we deleted the integral term that we had earlier. That would probably explain that. Oh, there you go. What are you doing? Because it's way too far away from the pad to try and save itself. All right. Very good, very good. Also, do we have our horizontal velocity controller set to 10, -10, 1.5? Okay, cool. That might be, we'll see. It might be a little much, but anywho. What mods am I using? Yeah, thank you, Bananer. Yep, those are the mods I'm using. Pretty much no part mods, essentially, and then just some quality of life mods, Parsa. All right, let's go ahead and time warp up again. looking good. And stop. If you get to figure it out, don't change it. Yeah, exactly, Space, exactly. No doubt. And it changed. Positive 50. Wait, what? Is that too high of an integral term? Is that what happened? Oh, I added... silly. I added derivative term. So that might explain some things. All right. Try it again. Hey, what's up, Jonathan? How are you doing? Yeah, it's been going pretty well. Think we were close? I don't know, man. I mean, we may have been, but before we start getting into changing the actual controller architecture, let's make sure and verify that changing the PID hasn't changed anything else. And try to get it working as is. I would like to do the cascading controller. I think that'd be really a clean way to do it. But let's get this working first. I can actually remove that line of code there. Ah, stop it. There you go. Just a little Astra maneuver off the pad. That's all it is, chat. Hey, what's up, Rio? How are you? Looks like a winner soon. I hope so. I hope so. Yeah, exactly, Space. Yeah, the proper way to do this would be to change the PID.py like we did, then get all of our code working again, exactly how we had it before, if not working even better because of the changed architecture, and then then commit, and then we can start messing around with it. Yeah. It introduces some randomness. Yeah, it does, I guess. You plan on designing the chopstick soon? No, not soon. I would not use soon as the qualifier in that. Yeah, honestly, we're probably not going to do chopstick sort of stuff until like halfway through next year. Well, hopefully not that long. We'll see. I feel like we're pretty close, having everything that we need to start like getting there, but no, there's still a lot of stuff in the way. Still a lot of code that still has to be developed. There we go. Now we're cooking. Yeah. There we go. Really trying to pick up that velocity. Why? Stop it. Oh, that's so funny. I definitely gotta put a stop to that. Yeah, it doesn't even have time to stop. Oh my lord, chat. Yeah, so that's coming from here, less than say 3,000, I think. Yeah, you should not start burning until essentially we flip over. So whenever that is, let's do it at 1,500 maybe. I swear, chat. You made the layer. Yeah, no kidding. Yeah, I actually think having it pitched down that far is probably actually not the move anymore. It's actually a little bit too far. It probably should be no more than like maybe 40 and not 60. Because that doesn't... We pick up vertical velocity, but not a lot of horizontal velocity when we do that, so... Yeah, actually, this can be... That'd be 60 degrees up. Yeah, maybe it can pitch up to positive 60, but negative, it should not go more than negative 60. Because we want it to start... We want it to pick up horizontal velocity and not vertical velocity. Right, if it pointed straight down, we're not moving towards the pad, so that's not how that should work. Yeah, Space Gravy. Right now I'm trying to get it to land on the launch pad because before I change the PID.py, change the PID controls, it was able to do that. So I'm trying to make sure that what I changed, it's still able to do basically what we had it, if not even better, you know, that sort of thing. Because if you've seen us testing this earlier, right? And by earlier, I mean like in the last several weeks, this thing can go up to 70 kilometers or even above it, track the pad, come all the way, and then land within this hexagon. I changed the PID control loop. Did I not change the... Wait, what? Did I change the wrong thing? I'm confused. -40. Wait, what? Wait, what was that? What am I printing out here, chat? Why was it -60 again? Wasn't it -60 before? That's our velocity pitch. Yeah, velocity pitch should not be -60. It should be no more. Or did I do the wrong change? No, -40. It should be no more than -40. What? Yeah, perfect. Yeah, exactly. Is that not? -60, 2B, yeah. Why was it commanding -60? It should be capped at -40. Now, I understand that these combined is -60, but that's not what I'm printing out. I'm printing out just the velocity pitch, and the velocity pitch should only be the horizontal velocity component, yeah. Interesting. Oh, and the game froze. Brilliant. Oh, wait, did it? Oh, there we go. Oh, Space Flight Simulator, yeah. You would usually burn at 15,000 or 5,000, but I caught it on your second try. Nice. That's pretty good. That's pretty good. Yeah, no, not quite the intended behavior. I don't know. Yeah, I don't know why it was commanding -60 again. Like, that's the only place? Oh, is it? Wait, no, yeah, down here. Should totally be fine. Also, for this one, let's definitely do the... Yeah, let's do that. Then it should be distance pitch and then velocity pitch. Yeah, it should not be -60. It should be capped at -40. For our horizontal velocity, -40. So, it should not do that. Please don't do that again. Yeah, 1 second. Wee! There we go. There we don't. Am I? What? -60 again for the velocity. I'm manually pitching up, by the way. Just, yeah. There we go. Now it's starting to pitch up. That's so strange. Oh, that looks good though, what it's doing there. I like that. So that's working, but why? Am I missing something? Are these different or something? Oh, I'm so silly, chat. I'm so silly. Do I need that negative? Also, why are you doing that, by the way? That doesn't make any sense to me. Oh, you survived. How? Never mind. I don't know if that negative used to be there. I think that could be a problem. I'm curious. Well, no, because it was pitching down. It was just pitching down to negative 60. So it was pitching down correctly. So do I need to subtract it? No, because that'd be the same. No, that would. Oh, is it the velocity sign is different? Yeah, stand by, chat. I think this will be pitching it up, though. Tank farm avoidance unlike that earlier launch. Yeah, no kidding, right? Yeah, I feel like that negative does need to be there to translate the, well, we'd have to either that or we just subtract it. Either way works. But we'll see. Yeah, see, it's pitching up now. Commanding positive 60. Okay, so that negative does need to be there. Either that or we need to change the sign on our velocity. We could do it that way. Yeah, we could do it that way. See what that does. If not, then I just revert back, put the negative sign there, and then switch the max and min. Yeah. I'm on KSP. I know. It's a lot of reverts. You're thinking hard. I get it. You can do it. There you go. Run it back. Don't know why it wants to do that. Anywho, it's fine. Just weird. Just weird that reverting causes that to happen. Oh no, that doesn't do it either. Positive 60. So yeah, no, it's not, it has nothing to do with the... How's the horizontal velocity? Because yeah, we changed that around, but it's still being positive. Interesting. Okay. Okay, so I did have it right, the original. I just gotta flip the positive and negative, or min-max rather. Whoops. Sounds good. So yeah, make that negative. I think I kept this negative up here, right? No, I did not. Boop. And then we should change the horizontal velocity. Make this negative 60 and positive 40. There we go. Cool. Yeah. I'd burn a little bit at 5,000 meters, but once you get further, oh yeah, it's all automated, so I can't really do anything about that unless I code it in to burn at 5,000 and stuff. We shouldn't have. Gosh dang it! Every time, chat. Stop it. Stop it. There we go. Wee. All right, now go up, please. Thank you. Yeah, go that way. Good. Gotta wait till you get the PC. Gotcha. Yeah. It's like the probe forgets disorientation. Yeah, it is something like that, Charties. I don't know if it's KSP or if it's like KRPC, the mod. Like, does that happen in KSP as well? Like, just the base game, you know, it has a different orientation until it like starts going or something. I don't know. Kind of weird though. There we go. All right, we'll see. -40, perfect. So yeah, we're starting to get our horizontal velocity up. That's perfect. All right, we're starting to pitch up. There we go, we're pitching up. Really trying to slow down. Ooh, that's looking good. Now we should start pitching down again. Yep, we are. Ooh, that's actually looking really not bad. Why are we aiming away, though? We should not be aiming away. All right, so that worked well. But it's doing something there at the end in 2A. 2A. Because we've now flipped orientation. So is there a negative sign or something I don't need? Like this one? You took away negative HVAL. I added that back in though, didn't I? So you're saying there needs to be a negative HVAL there? No, I'm pretty sure I added that back in. Or is it that negative 50? Oh, I wonder if it's that actually. It's the HVAL on 2B. But that's fine. That's working. That's working as intended. But when it goes to this and starts its landing burn below 1500, yeah, that one, it's not. I think it's this one because we're not actually lower than 50. I think. Oh yeah, there's one other thing I want to do here, chat, while I'm just thinking of it. That's fine. This one. Yeah, I think the min should be like 4 or 3 with how it's coming in right now. We can fix that later. We can fix that later. It seems to be a little fast. Just a wee bit too fast. Yeah, okay. All right, let's try that again and see. Because let me see. Let me actually print something here. Aim away. Otherwise, aim toward. I understand none of this, but it's fun to watch. Well, definitely ask questions. Ask all the questions. Also, can't you use one of the DLCs to code your rocket to launch and head back or not? I mean, they have a cow controller. You can't code it. There's no coding, but you can kind of take the cow controller and do some wizardry with it and kind of do a automated launch. Oh, you don't know Python. Gotcha. Okay. Is it trying to use aerodynamic effects still? Yes, it is. And I'm wondering if it's doing that, but too late. Yeah. It is still trying to use aerodynamics. But it should only do that essentially when the engine is like off or when it's like going slow. But yeah, we'll see. We'll see. Code a rocket to dock? You mean like RPOD, like in space? I'd like to think that we could do that pretty soon-ish. Not in a couple years, but yeah, we'll see. Yeah, it might still be the easiest. Like there are definitely organizations that like rate different programming languages, and Python I think is usually the easiest, usually ranked easiest. All right, looking good. Starting to pitch up now, trying to regulate our speed. Ooh, that's looking good. Yeah, I like that. Pitching up. Pitching all the way up. Slowing down. Nice. That looks great. It almost needs to be a little bit faster. Probably a higher proportional gain. It's not bad. It's just it's a little slow, I think. All right, go vertical. Oh, so there it goes, I guess. But then it is still trying to aim for it. Yeah, okay. It's a little much though. Skirt, skirt. So it is aiming for it. What do we see? What do we see? What do we see? So yeah, during 2A, we are aiming away. Oh, that's right. It's always going to print aim toward. Stupid. I should put an else statement here. But yeah, pretty much it's always aiming. Oh no, it's always aiming away. Yeah, it's always aiming away. I have to print out, I guess, my vertical velocity to check why that is. It's probably because the vertical velocity is too fast. You know what? Let me take this and put that away, and let's rerun it. I say Python is pretty easy relative to other languages. Yeah, for sure. Any news on Starship Flight 7? January. Yeah, like early January, second week of January. I don't remember the exact date, but oh, there you go. Yeah, January 11th. Are you able to graph the outputs to visualize what's going on? Yeah, I could. I think we do have that in here. And we have a bunch. Yeah, we do have some plots like throttle, altitude, vertical velocity. We have vertical velocity there. I'd have to set up more data streams to really see what's going on. Probably would have been worth it in the had we done that a long time ago. No. Okay. I was scared for a second. All right, coasting up, chat. Probably this might be the last flight, depending on how it goes. Ubernator, I'm about to head out. I'm getting the foggy brain. Go have some hot tea and get in bed again. You know. Hopefully, feel better tomorrow. All right, looking good. We're pitching down. Yeah, that's actually working really, really well. The horizontal velocity regulator. Hopefully tomorrow, Space Gravy, depending on how I feel. Yep, that's looking good. Not on the truck, please. Not on the truck, please. Oh, God, not the truck. Wow. Any book recommendations to learn more about rockets, propulsion, control systems, etc.? For propulsion, if you don't already have it, you got to get Rocket Propulsion Elements by Sutton. Definitely, that's a great one. It goes like beginner into intermediate level of propulsion. All kinds of propulsion, like literally every kind of propulsion. So if you're looking to kind of get a broad, fairly in-depth view of all types of propulsion, definitely do that. So Rocket Propulsion Elements. Control systems, it kind of depends. Specifically for rockets, believe it or not, I would recommend called it's called Tactical and Strategic Missile Guidance. It's an AIAA book, I think. Yeah, it's an AIAA book. Why is that one good? Yes, it talks about missiles, but a lot of that same stuff carries over right into launch vehicles, funny enough. That's a little bit more in depth though. If you're looking for controls in general, you can't go wrong with really any intro controls book like modern control engineering by Ogata. That's a good one. God, there's so many different types of control, so that's a tough one to say. What was the other thing that you were talking about? Closest landing yet. Yeah, I know, that was actually really pretty good. Channeling your inner Tony Stark. Yeah, something like that. Control systems, etc. Ooh, you know what's actually a good one? Do I have it on the shelf? No, I don't have it on this shelf. Here, one second. If you really want to get specific to launch vehicles, God, what is it called? Never remember. AIAA books, the education series. It's the one from 2022. It's like it's like everything launch vehicles. Hello, please, thank you. There we go. This one, Design of Rockets and Space Launch Vehicles. This one covers everything about designing launch vehicles. Everything from structural, everything from different types of trajectories. This is a great one. This is a really good one. I really enjoy this textbook. Yeah. So, yeah, that one. That one, if you want a big beginner to intermediate introduction to everything space launch vehicles. Rockwell has a ton of literature about PID modeling and tuning. Yeah, I mean, these are just textbooks, but like you could probably Google, you know, journal papers and you know, stuff like that. Go on NRTS, the NASA Technical Research Center or whatever. They have a lot, even though they're old, they still have a ton of really good knowledge in there that you can just read up on and stuff. Like for example, something I do want to implement on stream, NASA NTRS Unified Power, oh God, what is it called? UPFG, Unified Power Flight Guidance, yeah. NTRS, this is the guidance, navigation, and control algorithms that the space shuttle used. You can go in here and you can literally just find all of the maths, chat. All of the maths and all of how they calculated the throttle response and trajectory for the space shuttle. Yeah, this is a good one too. I want to implement this for our first stage guidance for all of our vehicles. I think that'd be really cool to do. But yeah, NTRS has a bunch of stuff. NASA Technical Report Server. Yeah, NASA, yeah, just Google NASA papers. I mean, even if some of it's old, you can find everything about Apollo in there. Like Saturn V's launch guidance algorithms are there. It's called Power Explicit Guidance, or PEG. You can find all the math and everything in there. Ooh, I just realized we just popped all the tires with our rocket here. Okay, I'm gonna run that back, chat, and we are gonna test it one more time before hitting it and calling it quits for the evening. So I wanna see all of that one more time. Repeatability, right? Landing on the truck would have been epic, yeah. Yo, what's up, Palangar? You weren't subbed to me yet on YouTube, but welcome. Appreciate the sub. Much love to you, my friend. Hey, what are we at? We're close to that 1,000 mark on the YouTube subscribers. The hell yeah. I got some graphs coming for you in a PR on GitHub. What's PR stand for? Like I said, foggy brain, chat. I've been a little under the weather, but yeah, what's PR? Private relay? Yeah, I gotcha. Should be ready for next stream. Awesome. Oh God, yeah. Oh, on GitHub. God, I keep thinking like private message, like Discord and stuff. Yeah. Thank you. Pull request. Jesus. Yeah, I need tea and sleep. I think that's what it's come down to, chat. Yep. All right, I got you. Let me. Do I have GitHub open here? No. There we go. Got it. I'll keep it pulled up. And I will await. It's all gravy. Yeah, been there, I know, right? You get that foggy sick brain. All right. Let's time warp, shall we? We don't want this boring launch trajectory. We want to see it land. You know what time you'll go live tomorrow? I mean, ideally normal time, like 7 p.m. Mountain. Is the idea, anyways. I'll let you guys know on Discord and if I can remember a YouTube post if I can't, if I'm not feeling good, but I'll let y'all know one way or the other. All right, looking good. Oh, well, Jonathan, if you're a software engineering student, please do not judge. Right now, the code is an absolute mess, but yes, definitely hope you enjoy it. I hope you can understand it. So yeah, about that repeatability, chat. about that repeatability. I mean, it actually handled What? What did it just do? I'm gonna hopefully revert here and chalk that up to KSP being a little glitchy. We're gonna try that again. No idea what that was. We have never seen it do anything like that. Oh, okay, that's normal. I mean, it's not normal, but that is KSP being just KSP there. Yeah. Okay. Code upload failure. Yeah. Was that the same code? Pretty sure. Should have been. Yeah. I gotcha, Space. Gotcha. Yeah, I'll also try to start posting on YouTube as well. So that way, if you guys are wondering if I'm going to stream one day on my normal stream days, which is Monday, Wednesday, Friday, and sometimes Saturday, Sunday, you can see if I'm not going to be able to make it. I did that on Wednesday. I forgot to do that yesterday when I wasn't going to stream. I know, right? Space Gravy. I mean, I know why. It would have been great had KSP2 continued. You know, because there's only the devs even said in terms of KSP1, there was only so much more they could upgrade it because the code is, you know, the entire game is how old now, chat? 12 years old. Like, it's still operating on older Unity and things like that. Like that, yeah. Like there was a reason why they wanted to go to KSP2, but unfortunately, the execution was not there. Like you can only update an old code base before it just requires a complete rework, you know? And remember, KSP1 started off as like, wasn't it a single developer? Like one developer, right? I'm pretty sure, right? It was one person, and you know, as you get more and more people working on it, code becomes spaghetti. And yeah, like I said, there's only so much that I think KSP1 can continue to be upgraded before just you should have a new game. There we go. This is looking. There we go, chat. See, this is looking a little bit better. Yeah, right on top of the. Wait, what? Stop. Stop. Aiming for the truck again. I don't know what it is about the truck, but wow, that is money. I mean, I'm pretty happy with that, chat. 40 meters. That's pretty good. Did you take the coordinates of the truck? No. Should not have. The coordinates should not. The coordinates should be static. Yeah, it's this. It's the takeoff point. It's the takeoff point of the vehicle is the landing site. So it took off from like right here. So I don't know why. Anyways, chat, that is gonna have to do it for me tonight. So yeah, I hope you guys enjoyed the stream. Definitely hope to be back here tomorrow, but if I don't see you tomorrow, have a good Sunday wherever you may be, and otherwise I think we'll be back Monday. Yeah. But anyways, chat, much love to everybody. Thank you guys so much for the new follows and the new YouTube subscribers. Much love to you all. Have a good one, and like I said, yeah, we'll be back at it here, if not tomorrow, Monday. Ta-ta.